Well, hello there, Internet, and welcome back to another stream. Hey, Arcane. Nice to see some early squad members. Yes, it is indeed. We're not just early in the stream, but the stream is actually kind of early in the day. So we'll see. It might be a kind of a slow stream today, but it doesn't matter. 1 second, I'm gonna try to untangle my cables here. Today we're gonna do some physics programming. Specifically, we're going to be doing sign distance field collisions. Try to make those work with the engine. It's not really something I've used before, and there's a reason for that, which I'll get to in a second. Alright, maybe that is fine. Maybe that is fine. Let's see if I can play the game here on this machine. Switched machines here again. After not really working on this one for a little while. And I do remember having the volume turned off. Let's see if that actually stays. If I don't do any audio programming or audio design, I kind of prefer to stream with the game audio turned off. And now it is indeed turned off, so that's good. Because we already have the music, the background music, and we have me yapping over the whole thing, so. Sort of depending on what we do, it can be nice to have game audio or not. And you get to hear the lovely squeaks of my legendary squeaky controller, which every time I try to demonstrate that, it doesn't squeak. But when I don't, you hear these squeaky sounds. It's my yeah, stuff like that. It's my 360 controller from like 15 years ago or something. Still being connected to this machine. I should really replace that with a newer one, but I kind of like this thing. It actually has like a bumper button, which is a little glitchy, which actually has had me debug my input layer trying to find a bug, but I think it is actually just this button, which is a little funky. Like you can open this radio menu here by clicking the shoulder button. And every now and then on this machine, it kind of you know, open it and then it goes away. And I I thought it was a bug in my input code until I realized it's probably actually my controller. Audio is okay. Well, thank you for reporting that. That's something I typically ask you guys to do. I don't think I did that today, but that's nice to hear. Nice to hear. And yes, I meant game audio in this case. I like to play without game audio when I stream. I am getting some reports of bad data rates here, though. Let's hope that doesn't tank the stream. We had a bit of a chaotic stream last time, both in terms of like just not my brain not working properly. So I was wondering about things I really shouldn't have been wondering about, but also we had some internet connectivity issues. And let's hope it resolves itself. I did a speed test just before this, and my connection seems to be really solid. So we'll see what happens. We'll see what happens. you're of course quite welcome to report, you know, not just audio issues but visual issues as well. It's probably the best way for me to realize if something is indeed wrong or just like very low quality. Just let me know in the chat and we'll see what we can do about it. So I have been doing a little bit of work on this level lately. I've just been doing like a whole bunch of different things lately. I did work a little bit on DXIL shader support for D3D12. We now have that. We don't have the other issues with D3D12 fixed yet, but at least I have the more modern shader compiler now used for D3D12, so that's pretty neat. And I have been working on this level, just trying to get it into a visually pleasing state, which hopefully is obvious if you've seen some of the previous streams where this was in a considerably less polished state. Of course, we still have like things like this building here being completely untextured and all of that. But we now have sort of grass painting and terrain painting done pretty much everywhere, the whole level. This is a pretty small level after all, so it didn't take that long to do. And I've also started to do a little bit of painting here on these cliffs. So this level is kind of like a test bed for a new style of making cliffs for me, and I'm sort of trying to figure out exactly how these guys should look. So I started doing a little bit of painting on these things here. Of course, we're still lacking light maps, which will add like a lot more sort of depth to the lighting here. But yeah, I'm thinking this is starting to look pretty okay. And then we have some things here. You can see these guys aren't really painted. They just have a little bit of the texture pattern going on. So these still need painting, and then we have like some completely untextured cliffs here still. So not really trying to do it all in one go, but in sort of like passes. Because I'm trying to figure out exactly what the art style is going to be. Frumius Gaming asks, what parts are Zig versus C++ and C#? So the gameplay code is Zig. So that means things like most of the vehicle code, the cameras, the you know, the sort of cranes and other things that you can do. Let's drive to a vehicle here that has an actual crane. Like the UI, these sort of things. Essentially, if you consider like Unity, you have the things that would typically be C# in a Unity game, or Zig in this game. So here you have like things like this cargo crane here, which you can use to lift things. The AI, so for your AI companions, the driving and all of that, that's completely Zig. And so on. So essentially all of the gameplay code is Zig. The engine would be C++, and then the tools are well, the tools are kind of like a mix of C# and C++. Kind of depends on what kind of tool we're talking about. Today we're probably actually going to have to do a little bit of tools programming. I don't think we're gonna do a whole lot of Zig stuff today. We might get to that. I'm gonna explain what we're gonna do in a little bit, and it sort of ends with some Zig programming. But I'm not sure if we're gonna really make it to that in this stream or not. We'll see. But we are probably going to have to do at least a little bit of mesh converter programming today, and that is actually C++ because it needs to interface with physx. But all of the like this editor here, for example, this is C#, and then it sort of runs the game, which runs both C++ and Zig code. So you can actually do like Zig code that runs in the editor through that sort of thing. that's basically what the split looks like. Right. So if we go back to, actually we can just place one of these guys here. There is this in progress vehicle here, which is called the gripper truck. It's called the gripper truck because it's supposed to get slightly similar gripper arm to but the gripper vehicle is another vehicle that was or is featured in the pre-alpha version of this, and a lot of people didn't really like that, and I kind of agree. I still think it has its place, but it's really just like a forklift essentially. And so I started working on a vehicle like this, which is kind of like a gripper, but also a vehicle that you can sort of like use to drive around the place. And it's supposed to be nicer to drive around if you want to drive some like longer trips, much nicer than the gripper thing. And this thing is completely in progress yet. And I was thinking today we would start with doing a little bit of physics and or phys-x work on this guy. You can see this blinking box here is something that phys-x calls the I think it is the mass frame, which kind of like tells you the state of the object, and I think that the shape also signifies something like the inertia or whatever. But what we really want to look at here are these red lines, and you can see that we have some collisions going here, and these collisions are made up of convex hulls. And so the classical way of doing dynamic objects such as cars in physics would be to use convex hulls, like a bunch of them, and then you can just make them dynamic so that the object can drive around. And we can see that this bed here, this truck bed, doesn't actually have any of those red lines yet, and that is because the truck bed actually doesn't have collisions. So if we if you drop like a box on top of that edge there, you can see that it kind of just goes through it. If you're careful, you can kind of drive things around with this guy, but that box is now actually sort of like lying on the truck and not the bed. And then if you're uncareful, it just falls off like that. Bloop. And so that's a little bit of an issue. And so we can do it two ways. Two ways to be able to add collisions to the bed. And one is to do it the same way I've done for this big one, the mother vehicle, is to actually model the bed out of convex hulls. So you can see here, for example, we have these edges here actually have collisions. And so if you add something to this guy, let's add one of these bigger crates here, and then we drive around sort of carelessly. You can see the thing sort of sliding around there, and it actually, when it hits one of those edges, it will stop. So it doesn't fall off that easily. But here you can get an excellent view into one of the issues here. So this sort of fixture for a crane or some other tool is actually not modeled with physics collisions, and so it kind of just like goes through that. So it's just like this whole back, and these things have some collisions and stuff like that, and then the crane arm itself also has collisions. So that can be done, but what we would really want to have is a triangle mesh. So sort of similar to this cliff here, which also uses collisions, but it uses like triangle meshes for the collision. The problem is that you can't actually make a triangle mesh dynamic unless you add sign distance field information to that mesh. And so that is what we're going to try to do today. Hey Paco, Anyway, to increase the mic gain a little. It's a bit hard to hear. The mic gain is almost at the red here, but let's see if we can actually... Can I boost the output of OBS a little bit? Let's see. All right. So what about now? Would this be better? If I talk like this and blah blah blah, game development. I'm trying to kind of talk roughly at the same volume as I did before. Is this better? So what I did was I went into OBS's advanced audio properties and bumped the volume a little bit for the mic channel, but I have a hard time actually seeing any difference or hearing any difference myself here because the input to the mic channel was already like in the yellow, so pretty much the sweet spot as far as I know. Anyway, let me know if you want me to bump it even more, or if this is good, or if this is, you know, too much. But let's try to go with this for a little while. Right, so as I said, we can add a triangle mesh to the object if it is a static object, which is how those cliffs work. Or we should be able to do SDFs, so sign distance fields, add sign distance field data to a mesh, and that should allow us to make it dynamic, which is something that I want to try for this vehicle here, because we're supposed to be able to tilt the bed of this guy, and so it's just easier if we just have one mesh that we tilt, you know, around the axis, essentially. Still low, maybe a tiny bit better. Okay, let's do it. Raise it even more. Something like this, maybe. Is it better now? Blah blah blah. Game development, 3D modeling, game design, level design and texturing, and you know, audio design, maybe even some composing. Let's not forget making coffee. All of the things and others. Rightio. I want to be a little bit careful with that, so I don't blow out your ears. I prefer to be a little too loud than a little too low than a little too loud. But again, as with everything, just feel free to let me know if you want me to go one way or the other. And of course, if you have any tips on how to actually boost, what is the best way to boost the audio from like OBS, feel free to let me know in the chat. I appreciate any and all tips. I think my audio interface can still boost it higher, but like I said, like the mic input to OBS already looks like it's in the yellow. Have you ever looked into SDF global illumination like Godot does? I have, yes, a little bit. I have done that a little bit. I don't remember the exact way Godot does it now. Do they do like voxel cone tracing or some version of that? It's pretty nice. I have even played around with Godot a little bit and tried out some GI stuff. And I I do a little bit of SDF fake stuff. You can see here underneath this vehicle, the grass, which is shell textured, so it's a little bit tricky to light properly. You can see that it kind of looks too bright, right? Looks a little too bright under the car. It looks pretty good in other places. And I actually have, I'm using SDF. I wouldn't necessarily call it global illumination, but I'm using SDF to do lighting for the vehicles specifically. So you can see under this Scout, it kind of looks a bit better. It's a bit darker under the Scout compared to under the in-progress truck. And so I use SDFs for that to sort of help flesh out the lighting for certain areas. But yes, worth mentioning that like this area doesn't use light maps yet. So I'm using light maps, pre-calculated light maps for the static stuff, and then light probes for the dynamic objects. Let's see. If we go to the demo level, it's not perfect, but okay. Okay, well, okay. Let's do this. I'm gonna bump it a third time, like this. So now it's at like plus 3.5 decibels for the mic. If this is too loud, let me know, right? I don't want to cause any ear bleeding in anyone. But it is now bumped, and I think like YouTube does like audio normalization for the VODs afterwards. And this is probably gonna freak that system out because I've been raising the volume a few times now, so I don't know what it is going to settle on. So if you're listening to this as a VOD afterwards and it just sounds weird, I apologize for that. Let's hope this is a reasonably good audio setting. But anyway, let me know if this is now too loud, and I will bring it back down a little bit. Actually, yeah, we went into the red one there for a little bit. So let me like just lower it by like 0.2 decibels or something. Right, so this is another level. This is a level where I kind of like don't like these cliffs now, and I feel like I probably have to redo them because this is using the old style of cliff modeling. But this is using both light maps and light probes. So light probes are used for the dynamic things, and also some things such as the leaves on the trees that are animated. And so if we go here next to this slightly darker area here, and this looks kind of okay, I guess, but then if we turn off light probes, you can see that like it affects some of these dynamic objects and even semi-dynamic objects like those animated leaves there. And if we turn off light maps, then just everything just looks way too sort of flat, and the grass just looks very, very weird and dark now here. But like the light maps do a lot of fleshing out and making the lighting a bit more deep, if you will. So that sort of thing is completely missing from this level still. It will come when I have the assets in a slightly better, slightly more final shape. Okay. You're far from being too loud. I'm using headphones. Okay. Okay, well, let's keep it like this, and I'm probably gonna have to investigate that a little bit, like some tips and tricks for how to make myself louder on stream. But I hope this is better. Okay, so what we are going to do is go to, let's see, physx guide. And we are specifically on 5.5, so let's go to that version. And we will go to... is it maybe collision? SDF? Yes, dynamic triangle meshes with SDFs. So sign distance fields. This is something that previously only used, only worked with. Oh, we need to go here actually, and then SDF. Yeah, here we go. Good morning, Marcus. Welcome, welcome. It's not really morning here, but good morning to you. Let's see. So this is something that used to only work with a GPU pipeline previously. If we go to 5.4.0, note that they are only available using the GPU collision detection pipeline. Well, this was actually removed, this limitation, in 5.5, which is what I'm using currently. And I don't actually use GPU accelerated physics. I use my GPU for actually drawing the graphics. So this hasn't really been an option for me so far, but now it is, and I want to try this out. So what we will need to do here is basically add this px SDF description to the place where we cook that physics data, right? That mesh data, and we need to somehow make it available to. Or we need to add an option to actually cook physics SDF data for a mesh. So we need to add it to the mesh converter essentially. And then we need to be able to tell it to not only generate physics data for the mesh, but also SDFs. And so that is my plan for this stream, to be able to just like have a convex mesh that we drop here into the level, and then see it bounce around without having to do any sort of decomposition into like convex hulls or anything like that. Let's see if we can find the what is it called? It's probably called something like smoke. Yeah, refinery smokestack. So this is it's like an object from that other level, which is made up of a couple of these convex hulls. Actually, technically, I guess these are just like cylinders. You can see like it's a bit bent, so it's not actually convex. It is concave, and because of that, I need to have like one cylinder here, which ends here, and then another one that goes here, and that is so that this guy can be a dynamic object. And this would be something that we can maybe test using, or not. I don't know. Maybe I'll just want to like create a completely new object type to test this, like an L-shaped thing that we can just like drop somewhere and have it collide properly. So we'll see. Lots of questions still. I don't really exactly know what we need to provide for the SDF thing, but let's just get going and see what we have. So a little bit of coffee. And let's go. Close all of that. I think actually what we'll do is we will search for some. I think there was a snippet that used this in the PhysX SDK. Probably here. And let's search in CPP files. And we'll call it px SDF def. Isn't that what it was called? No, it's description. That guy. That's what we want. You could add compression, filtering, EQ, and master output to cut out unused frequencies, make the sound tighter, and then with EQ and compression boost loudness without creating distortion. Okay, yep. Might sound complicated, but it's pretty easy. I was a former audio designer, so sorry if I got a bit nerdy there. It's absolutely fine. I don't mind people getting nerdy. No, someone might say I'm very nerdy myself. So it's absolutely fine. I do a little bit of audio design myself for this game, so I do know what most of that meant. if we say it like that. Okay, so we can see here. This is from a snippet. Then we have some internal stuff. We don't want to mess with this thing here. And this is also internal stuff. We have one place here which actually does the SDF. This is actually snippet SDF. So we need to provide it with something called SDF spacing. And then we have SDF subgrid size defaults to 6. Bits per SDF subgrid pixel defaults to this 16 bit per pixel. Then you give it a number of threads for SDF construction. And then you just set it to the mesh description. The SDF description of the mesh description, and then you cook it like you would normally do. PX cook triangle mesh. I bet if we search for that in my code, we will find it. It's right here. So this is in cook mesh. This is what the converter ultimately calls. So we have the cooking params, source geometry, load level index, and then we have an output stream. And we need to basically tell it, hey, what if you would add SDF data to this, right? So here we have the triangle mesh desk. That was the same thing here, triangle mesh desk. We fill out this guy with all the mesh data, and then we assert it's valid. So here is where the SDF stuff would go. Yeah, but essentially the only thing that they require us to do here in the snippet is give this SDF spacing. So what would that be? Spacing. You can create one of these guys here. So that would probably be PhysX. No, just like that. And then spacing. The spacing of each SDF voxel. Okay. So basically like the size of the voxels. You can see here that SDF colliders only work when the GPU solver is used to run the simulation. They haven't updated the comments here in PhysX itself. But the release notes say that it's now working with its CPU. We'll see if that turns out to be the case. SDF spacing. If SDF spacing is larger than 0, then we do this. Otherwise, we essentially don't add any SDF data. That's pretty cool. Let's just copy this guy then. Yeah, it sets it on the mesh desk there as well, right? So basically this SDF spacing, we don't obviously have that yet, but we will in a bit. So let's just, subgrid size can just be 6. And we can just use these physx 16-bit per pixel. So SDF spacing, cook mesh is right here. And we can set that to -1, right? That would then mean the same as before, no SDF data. That makes sense. Let's add a to do here. Expose these. Oh, that's not what I wanted. Yeah, maybe the threads as well. 16 is a bit high. Let's not assume we have that many to use. Let's do 4 and see how that works. Right, so mesh desk is used there. SDF desk. I think this guy has a constructor. Yes. Can we just jump to that here from here? We can't, but I think it sets it to 0. Well, I mean, it evidently sets it to 0 because it hasn't tried to use it previously. It just checks that if we have an SDF desk, that it is actually valid. Yeah, okay. That should be good. I do think, however, that that this cook mesh function here probably comes from this try mesh. Oh, it doesn't actually. Yeah, okay. Yeah, we just have some very basic things here. Okay, that's fine. That's fine then. So cook mesh, and this should even build now because we have a default value there for it. But if we go to the mesh converter, that's material converter, mesh converter, and then we look at, is it maybe converter? Convert physics mesh, exactly, yeah, okay. So we have serialize, physics engine serialize try mesh data. What does this do? It probably eventually calls cook mesh. All of these layers are here, of course, because I abstracted some of this stuff, some of these things away quite well. Right, so serialized try mesh data actually calls cook mesh here. So here is now where that new SDF spacing parameter is added. That's good. That's good, that's good. And this is now something that we will have to probably... Yeah, we have to add the parameter here somewhere. So we give it a source geometry, mod level, target buffer length, and then a result like this. Why don't we just like return that result? This looks a little weird. Why is it given like as a thing like that when we could just return it? Am I somehow afraid that this is going to be large? It's really not large at all. Okay, so let's do a little bit of refactoring here while we're at it. So basis physx backend, you'll see that there's actually no mention of any physx stuff on this level, and that is because I do support other physics engines besides physx. So this is used with those other ones. But what we will do here is just do that instead, and then we will do float SDF. What was it called? Spacing, I think. SDF spacing, yes, SDF spacing. And I don't have any qualms just adding it here, even though it is pretty physX specific, because physX is sort of like the main sort of backend here. I am thinking about like we have like input, and these are essentially output parameters. Should the spacing just go like here on next to the LOD level maybe? Then I can't give it a default value, unfortunately. Let's just leave it as it is. It's probably fine. So right, so SDF spacing will be the last one, and instead we will return the result. Yep. Let's see what we have. What is that actually? We have the result code, and then we have the data length. Right, so this, as you can see, it doesn't really support any sort of cooking at all. And this is the bullet backend. So that's fine. All right, we have some questions here. Let's see. What build system do you use for C++? Are you just pulling all together in Visual Studio, or do you use CMake? I do use CMake, yes. I do use CMake. Premake is probably also fine. I have a little bit of a love-hate relationship with CMake. I used to like it quite a lot, but the more you actually write in CMake, the more annoyed you get at the CMake language itself. So I have a pretty good setup now. Let's see if we go into one of the CMake files here. CMake for the mesh converter, for example. So you have the sources here. Just when you have this stuff set up, it's pretty easy to work with, and it's sort of rock solid. Works really well with, well, it generates pretty much anything. So you can expect whenever there's a new Visual Studio version, you can expect there to be CMake support for it pretty early on. And so just adding stuff here, for example, is super easy. And then I can just go like, okay, so mesh converter privately links to my core engine library, and it also links to asimp, which I use to convert the geometry. And then if you have, OS animation enabled, then you just link to base geometry, blah blah blah. And if we use the official FBX SDK, which I don't currently do, then you link to those guys. This sort of stuff is pretty nice, but it's kind of annoying to set up. Another one, and probably the one that I would use if I were to start today, is Ubisoft's SharpMake sort of thing. So this is very much like a similar thing. It is geared towards, I think, Visual Studio and Xcode. SharpMake can also generate makefiles, and Xcode projects can be run natively on modern OSs. It doesn't really have it's not quite as cross-platform as CMake, but this guy uses C# as the scripting language. So I would definitely look into that. On your Zig part, which math lib do you use? I really enjoy working directly with vector for spatial, but the access by index and not by axis can be confusing. Looking for a better solution. So I have used Zig for long enough that I don't remember if the vectors were there when I started. This was around like 0.5, maybe 0.4. But for various reasons, I didn't end up using them. Like I said, it's possible they weren't even really a thing back then. But whenever I tried using them, I realized that, okay, I'm gonna have to actually convert like a whole lot of just conventions between what they do and my own math library. Or something. I don't exactly remember what it was. But basically what I did was I just implemented my own stuff, right? So, you know, it is not SimD because of that. Listen later, it's fine. But if you go to like, you know, 4x3 matrix, for example, it's just linear math for now. I don't do that much heavy math stuff that this would really be significant in any sort of way. And this allows me to have the exact same memory layout, exact same conventions as I do on the C++ side. And I can also, you know, serialize and deserialize one of these matrices exactly the same as I do on the C++ side. Or the C# side, or whatever. I just have a deserialized function here. So that's how I do it. And it is probably not the most efficient, you know. Concatenate with another, it's a whole bunch of multiplications. But so far, like none of this has really ever shown up in any of my profiles. So until it becomes a problem, I'm just not gonna bother. Alright, how are the DLL plugins for physics loaded? Are those DLLs just loaded by the launcher, and then the function pointers from the DLLs are supplied to the engine? Right, so I don't do any physics function pointers myself. I have a plugin system. Let's see if we can find here's the physics 5 plugin. We also have a physics 4 one, which is simply called physx. And then we have a bullet one somewhere here. Where's it? There we go. Basis bullet. And actually the D3D11 and D3D12 backend, these are using the exact same plugin system. These days these are just backends for NVRHI, which is why they're relatively small. But see if I can even remember how this works now. Is that one maybe? Oh, it's this one. Right, here we go. Right, so we have two functions essentially. Let's just go back to physics because that's what you asked about actually. So the plugin is here. We have two functions: create plugin and destroy plugin. These are marked as extern C, so they get exported as C functions from the DLL. If you load a plugin and you load it as a physics plugin, it is expected that this guy gives you back a plugin which derives from this base plugin class here. And this has some things that get called at certain places. So after all plugins loaded, before all plugins unloaded, and then we have client before client created, after client created, and then destroyed. So the game engine is a client server version, client server architecture system. That's why we're talking about clients and servers here, even though we don't really technically use them for anything here. But then it creates this basis physx5 plugin, and this guy actually registers itself with the engine. So you shouldn't try to load two physx plugins, because they will try to register themselves with the with the core engine. And because this DLL links to the core engine, it can just call register backend with, you know, with itself here. So this backend thing is created, where is it actually? Right, it's just here as a member of this plugin thing. And this backend implements physics engine backend. And at this point, if you pass this guy to the core engine can then just use this physics engine backend interface. It has a bunch of virtual function calls here. One of which is the thing that we're actually working with right now. So serious tri-mesh data is here. At this point, you can just call them normally from the core engine, and everything just works. You don't have to mess around with any function pointers, nothing like that. So that is how it works. Hello, Matt. Welcome back. All right, let's keep going. Feel free to ask questions if you'd like to know more about this. I prefer that people just ask me rather than me rambling on about things that, you know, no one really asked about necessarily. So we have a few places here more to fix up this thing. This was supposed to be the SDF spacing stuff, and then result is not that actually, but rather something like that. And then let's have a look here. So this is supposed to return one of those guys now, right? Like so. Declaration is incompatible. Oh, is that why it used? Because it's like I don't need to. Let's see. SDF spacing. Let's see if this builds. Must return. Yeah, okay. Yeah. So if it is not successful, at this point we want to return probably just result, right? If it is, if target buffer length is big enough to hold, then we copy the thing. Otherwise, we set the result to too small, and then we want to return the result again, like so. So that now should build, I think. Yes. Okay. Good, good. And this should be basically exactly the same as we have here. And that's supposed to be float SDF spacing. Return result. And should these guys now actually have the default value? I think they probably should. Right? Because they're implementing this, or well, yeah, implementing this base class, which has it. And the bullet one. Yeah. Yeah. Right, and then the physics engine has one, and this is really just like a wrapper around the backend, essentially. Which in some cases seem a little strange, but there are a few cases where it's important that we do this. So float SDF spacing, and this is supposed to be just return SDF spacing. Whoa, spacing. right? Nope, not that. Yeah, this looks good. And then of course we can just do this instead. And we can pass -1 there for now. Actually, let's do float SDF spacing. And pass it instead. And so negative, the value means no SDF data. Right, something like that. So just quickly go over this logic here. This always returns result code failure. That's the most annoying warning in Visual Studio. Prefer Indium class over enum. It's like yeah. Complains about things inside of physics itself as well. And here we get a result. We have a write buffer. We have a result. Want to copy from this physx write buffer into our own write buffer, which is just a raw byte buffer. So check this. We check if the result is not success, we return. And that would already have the correct result, right? So it can be like buffer too small, failure, or large triangle. Essentially, one of those. If it is success, just check if the target buffer is large enough. Or otherwise, we set this result code. Yeah, so that looks good. That looks good. That looks good. We should be able to basically build both the mesh converter as well as the core engine. And once we have this, we need to go into, we need to actually modify just a whole bunch of different things here. Once we have this working, we need to be able to tell this mesh converter somehow, okay, please generate SDF data for us. And we do that by setting this to something other than -1, right? So we can add a value here to the converter settings to do that. Let's see, do you notice any performance difference between your RHI and NVRHI? Very little. Very little. If we're talking about D3D11 here, I would say there's very little difference between them. In many ways, they were very similar, which is how I was able to convert the entire engine to use the NVRHI over like 2 weeks, 2.5 weeks, whatever it took. But yes, very little, if any, performance differences between the two in D3D11 mode. D3D12 is well, it's probably not faster, it's probably a little bit slower, and I think like in particular the loading tends to be a little slower. That might have been mitigated a little bit with moving to DXIL shaders. But I haven't really profiled it enough to see any difference. Rightio. So that succeeded. That's good. So convert physics mesh. This is called from asimp converter. So, and this guy is called from probably the main function of the mesh converter. So the way this works, let's actually start from that. If we go here to the level editor, let's now reload this now that we can do it. So unloaded the back end of the editor so that we were able to actually poke at those DLLs and all of that. We have like this mesh here, right? This is called depot level specific cliff number 3. So if we go to the asset browser and then we go to depot, let's add start up a preview here. So level specific, and we go to cliff number 3. So it's this guy here, and we can see that it has these yellow lines. So these are, you can see it perhaps even better from below. That it has this physics representation here, right? And the way we do this is by let's see, where do I want to put it? Over there, maybe. Yeah, this is all completely messed up. This layout here. I don't want this at all. I've broken my layout somehow. There we go. So the way we do this is by creating a static body transform component and setting the shapes. So we have one shape with index 0. You can add more here if you want to. Blip, blip, blip. Let's not do that. And it's set to tri-mesh, and we use the same binary mesh file here for the shape as we actually do for the rendering. It's using the same here, cliff number 3, depot cliff number 3 bin mesh. It's using depot cliff number 3 bin mesh for the physics as well. And so if we go to depot cliff number 3 bin mesh, actually FBX in this case, you can see that it has physics data enabled here. And we want to basically add another checkbox here to this, which tells us that, like, yes, we want to actually be able to generate SDF data as well. And I don't exactly remember how I did this UI thing here, but it would be pretty cool if we could sort of nest the SDF stuff under this physics data checkbox, right? And then that would essentially generate data for this. And it works the same for the vehicles as well, except we don't do static transform components, we do dynamic ones. So how do we get the data then to the converter? Well, we're gonna have to look at some tools code. So this is like a pretty small change, essentially just a few lines of additional sort of definition code or declaration code, whatever we want to call it. So try mesh 5, like this stuff. This stuff is what we want to actually run, but it just like jumps all over the entire project to be able to set that, whether we want to run it or not. Let's go to asset browser. Is it maybe that's UI probably. Mesh editor control. Yeah, and it doesn't show it to us here now. That's fine. I want to view the code anyway. Yeah, this is like clearly copy pasted from somewhere. So here we have those checkboxes. Vertex format data, physics data. Yep. So it is very manual Yeah, I think this is actually for the image assets. So I just copy pasted that and and made it into a mesh one. I'm gonna make the code slightly smaller so I can see a bit better what we have. Yeah, clearly copy pasted from somewhere else. There's like years old stuff that we have here, but it's fine. And basically what we want to do with this is we want to write to a mesh metadata file. Save to JSON. Yes, exactly. Exactly. So generate physics try mesh. These booleans here essentially map to those checkboxes that we can see here. Cliff number 3, FBX, these guys. Linear vertex colors, optimized geometry, physics data. Yep. All right. So let's maybe start with this, because this is sort of like the thing that keeps the entire state in memory as well as on disk on the tools side. And then this can be modified with the asset browser, and it will be read by the mesh converter. Where's this thing actually? It's found in basis tools lib, so it's like in the very sort of base library. So I'm just going to add another boolean here. Oh, come on. These days I would probably do this with properties, but I haven't done it here because this is so old code, so I'm just not gonna change that now. Generate physics SDF. Right? Quite simply. Maybe at some point I will go through and clean this up. Print metadata. Something like that, and then this is done in a very manual way. This whole reading of stuff. Write your end array, and then we just do that and just write it there. Even though this could be sort of serialized and deserialized automatically with Newtonsoft's JSON stuff. I don't do that here currently. Okay, so now then, now that we have that, we can go here and we can add another one of these checkboxes. So private const int mesh metadata generate physics SDF ID. That would be 5. So let's not try to be fancy here and instead just do the bare minimum that we can get away with. Right, so I have sort of a property here which is used really just to like set up this checkbox feel and the checkbox look. Whether or not to generate physics SDF data for the mesh. Physics SDF. Right. This is a little archaic, but but you know. Don't break what ain't broken and all of that. I think actually after this, what we should do is we should go into Blender and just model that L-shaped thing that I spoke of. And so that we have something to work with here. Yep. All right. So this looks good. Where was the saving to JSON? It's right there. And load from JSON is also somewhere. It's probably here. Yep. Exactly. All right. So now if we run this, shut down the other one. Make that the startup project. So if we go to any mesh, we can go to that aforementioned cliff number 3. Now we have physics SDF data here. And if we save this, just set that to true and we save. You can see save the mesh metadata and requested a conversion for the mesh. If we explore to this guy, we can see that it has an fbx.meta file, which has some changes. And the change it has is that, as you can see down here, generate physics SDF data true. And this file is now what we can actually have the mesh converter read. Right, so I set it to false and saved, and now it's set to false there. Now, of course, we don't really need that, so we can just do a revert. Yep. And it is just implicitly false. But now we want to actually create something that we can mess around with at runtime to see if the collisions actually work. So let's do that. Let's do we actually have some sort of development blueprints in the game? Yes, SDF test shape. That sounds pretty much exactly like what we want here, but this is actually the SDF stuff that I spoke about, which is used to color the grass and other things. So it's not actually the same. But does this actually have some object debug? Okay. So we go to objects, debug, and this has some like very basic things like a box as an obj file, this sort of thing. Yeah, it has a scale mannequin, which is like the human-sized mesh that we can use to work with scales and all of that. Let's make a Blender file in here, which we call something like the concave shape, right? So concave shape. Start with the cube, as you do. Let's see how large is one of those scale mannequins now. Okay, so it's pretty large actually. So we're just gonna do 0.65, 0.65. right. And get rid of that guy. Bye bye. And the interesting thing now is like, okay, where should the pivot be? Should it be there where it is currently, or what? Well, maybe we'll leave it there for now. We can do a smart UV project. And this looks kind of decent. So let's put it here. What it was supposed to be called convex. Not convex, sorry, concave. Concave object. Quite simply. And we can export it here into the objects with the correct settings. And we don't need to do anything anymore in Blender, as far as I know. So here's our beautiful concave object. And now if we refresh this and we search for concave object, we can set it to generate physics data and physics SDF data. And now we can see that we got this meta file generated for us here. License upgrade required. Really? What? Oh, I can't indent it. But the important thing is that we have this generate physics SDF set to true here. So that's nice. And we can even go here to the game. Should be in bases. We're just going to put it into the game side. Let's call this development. We can call it static concave object. Just to get started. And I'm going to remove this transform component here and let's add a static one. So static body transform component. This allows us to do tri-mesh and concave object bin mesh, like so. And we can add the mesh component to it so that we actually get to see it in the game. Let's do concave object and just add one of the blockout materials. So blockout, I don't know, blue maybe, something like that. And now we should be able to see it here in the game. So here we can see we have the physics data coming through and everything works kind of nicely. Excellent. Actually, one thing that we will need to probably tweak here in the asset browser as well is like if we have a dynamic body transform component, if we add that to the thing, you shouldn't have both a static and a dynamic, but let's not actually save this now. So when we make the dynamic body or dynamic concave object, we can't actually select tri-mesh here for the dynamic body transform component. Because so far we actually haven't supported that, but now we do. So that's something that we will have to keep in mind when actually. We can just remove that guy. Okay. Okay. Convex hull and then tri-mesh. I think so here we have a dynamic one. It supports convex hull. There's one other, I think there's like a plane one which it also doesn't support. Yeah, we have a plane here, the static bodies. Can't have a dynamic plane in physics. That would be kind of crazy. Because a plane is infinite, so like how do you actually simulate like a how do you simulate a dynamic plane? It's sort of like cutting the world in half by adding a plane somewhere, and then like how do you simulate a dynamic cutting of the world in half? Do you use any additional libraries for the Windows Forms GUI? Was it built purely by you using only WinForms elements? I use a few, yeah. Yeah. In the editor I have this thing here, uses something called Better List Box, if I remember correctly. And this is using better thumbnail browser, so they're made by the same company. And then these things here are, as well as like the inspector, if you select something you can inspect its things here. It is called Smart Property Grid. And then of course like this whole docking thing, the fact that you can like dock these together, sort of like Visual Studio. That is Dock Panel Suite. And then for the scripting, so if you have a scriptable object like a vehicle here, you can script it right here in the editor here. This is using the Scintilla.net script editor component, or text. It's a text editor. But yeah, other than that, I think it's essentially just WinForms stuff. And then I have some unholy hacks to allow me to like customize the scroll bars and things like that. So I'm like too nasty to even explain how they work. But thank you. I hope it looks nice. I hope to release these tools to you as part of an upcoming pre-alpha build. Not exactly sure when that is going to happen. Okay, so now we have this object here, and we can even, if we do just a no, don't need to save anything, just do a reload of the backend. Concave, static concave. We should have the thumbnail rendered in a second. There we go. We can place these things into level, and they should behave as we would expect. But of course, the interesting thing then comes when we start to add the dynamic ones. So here we have a physics. That's fine. Okay, interesting. So now then, let's make it so that we can create a dynamic one of these, which is like orange. And that sounds not that difficult, but it's actually quite a few places we need to mess around with to make that happen. I'm going to have a quick toilet break, and when I come back, we're gonna start working on that. All right. Toilet breaks over. Let's get back to work. I'm going to plug the Discord a little bit here while we're at it. So, like I've said so many times before, and probably will again, if you want to play the game currently, you can, but you need to join the Discord to get your hands on a build. I'm planning to do a new build reasonably soon. So the current build is the pre-alpha 1 build, which allows you to play a single mission from the campaign. And pre-alpha 2 will be out hopefully during the summer, or even before my summer holidays. That's what I've been hoping for myself here. It should be a lot better, so you can also work, sort of wait for that if you want to. That may be released on Discord as well. I'm going to start releasing builds on Steam pretty soon, but I'm not sure Pre-Alpha 2 will actually be on Steam yet. Pre-Alpha 3 will be for sure. Pre-Alpha 2, you might still have to join the Discord to get your hands on. So you're free to wait for number 3 if number 2 doesn't get onto Steam. But in the meantime, if you want to mess around with the build, Discord is the place to get your hands on a download link for that. And you're of course free to just share it with whoever you want, but I don't give out the link quite yet because the build is still kind of early, so if you run into any issues, then it's better that you are there on Discord and can ask for help there. Hey Wookie, good morning to you. And welcome back. Alright, so now we have arrived at the mesh converter. So if we look at the main CPP file here, we have some settings, such as generate physics try mesh, which we've seen before. But of course, this is now C++. This is not C#, where we just added this thing. So there's a little bit of duplication again, once more here, which is a little regrettable maybe, but doesn't really matter all that much. But basically, we want to add a generate physics SDF flag here as well. Let's search for all the places where we call this other one. Alright. Generate physics try mesh. Essentially, generate physics SDF doesn't really matter if you're not generating physics try mesh, right? So yeah, we're initializing the physics engine to be able to convert the physics data if this boolean init flag is set to true here. We're doing that if, let's go back here. We're doing that if settings.generate physics try mesh is set to true. So we're creating this thing here. And then we are also calling convert physics mesh here. And it gets the settings passed to it. So we shouldn't need to change any of that stuff. That's good. Okay. Now, of course, if you remember from previously, to be able to generate the SDF stuff, we need to actually give it the SDF spacing value and give it like a positive floating point value for that. What we're actually dealing with here is a boolean. So I think I'm probably just going to hard code the value that we found there in the physics snippet. So if we go here, you can see this was the SDF spacing stuff here. Create mesh, see where we call that. So they're just using 0.05 F here for the spacing. Maybe we'll just do that, do the same for now, and then maybe later on when I know exactly how that sort of affects things, then we can make it adjustable somewhere. So no settings files, use the default settings. Well, then the SDF should be set to false. And here we have a read bool setting. And I think the last one is probably default value, so let's set that to false. What do we have here? Mesh appender. Right, this is some old stuff. Yeah. Mesh appender is like if you are running this in some very specific mode. Yeah, parameters count append. Then it just like appends one to another. That's fine, we don't need to touch any of that stuff. That is completely fine. Alright, so now we should have everything we need. This guy doesn't write anything, right? Just reads. I think like previously the mesh converter used to write the metadata file there if it didn't find it, but that's been removed. Some time ago. And by that I mean some years ago, probably. Okay, so now the rest of the stuff should be here inside convert physics mesh. And here we have it. So let's do something like this. If, let's see, how do I want to do this? If settings dot generate physics SDF is true, then we do 0.05 F. Otherwise we do this essentially. To do value of 0.05 F taken from the SDF snippet in the physx SDK. Actually, that's not the to do. That's just a comment. But then we have to do. Figure out a good default value for basis plus make adjustable. Question mark. Something like that. That's already unloaded, so we should be good to just build this. And that built. That's interesting. Let's make sure that let's see, main generate physics SDF. That is the string that, oh, starting another Visual Studio here. No, thank you. Yeah, that is the name that we write it using. That's good. Okay. Okay. So we're actually kind of close now to having this work. I hope. So what we need to do is we need to update the mesh converter, and that goes in this __ tools folder here. That's where we have all the project specific converters, and we just need to basically take them from the release folder. Let's make sure we actually built it in release. Yes, release. So let's do, we will need the physx backends, and then we need the core engine library, and then we need the converters. Let's update them all in one go, even though technically we didn't update those other ones. but they all depend on the core engine, so let's just keep them all neatly tied together like that. And that's it, really. I do wonder if we should just for debugging go here to convert physics mesh and write here if SDF spacing is larger than 0, then we do basis printf generating SDF physics SDF data as well, just so that we can see that it's actually going to do that, right? That could be a good thing to have. We just override those things there. Okay, so now if we go to basis tools again, and we open this up, concave object FBX. So we can click convert here, and it should convert it for us, and we can get the output here from the asset server. We can see that it did objects debug concave object bin mesh updated. I can probably even make this a bit larger, and conversion output is here, and we can see generating physics SDF data. Now if we take that away, physics data, and we just save it, it does it again, but now it's just writing converting physics mesh, no mention of any SDF data. Turn it back on, and now we get the SDF data again. So that's good. At least I mean, we don't really see if it has SDF data yet, but at least the converter is reporting that it is in fact converting it. And here we can see the whole command line that is running. So project basis blah blah blah, convert concave object FBX, and then it's writing it to a resource. So how do we now make that into a dynamic object? That is going to be interesting. Like we can take this guy and we can duplicate it, and we can call it dynamic concave object. And rather than having this static body transform component here, we can add a dynamic body transform component. Just move it up here. And this should work. Here we can set the mass. The mass of this thing should probably be, I don't know, 500 or something at least. It's not kinematic. No continuous collision detection. We don't need to, do any center of mass things or anything like that. What we want to do is we want to mark this as being dynamic, the actual render mesh. And then let's not have it be blue, but some other color. So let's make it like, I think brick is this reddish, almost orange color that we had for some of those things. And this should now show up here in the preview, like so. So we have the static one and we have the dynamic one. The problem is now that we can't actually select try mesh here. So that would be the collisions or a sphere or whatever, but we can't select try mesh from here. And I've never done this, so I don't know exactly how physics is going to react to this. But what we should be able to do is this. Shut this down, and we go here to metadata and to component UI definitions and basis. And here we have like a whole bunch of metadata about different components. So we have the dynamic body transform component right there. Let's open that up, and we can see here all the shapes and things that it supports. Dynamic shape description. Right, it's actually the dynamic shape description that we want to look at. So we have the static shape description and we have the dynamic shape description. And here we can see that the type has try-mesh on the static side. It doesn't have it on the dynamic side, but let's add it there. And I wonder if this is just going to break everything kind of spectacularly. Interestingly, it already had this try-mesh section here, even though it didn't have it in the types. It's set to resource mesh, try-mesh. It's visible if type is try-mesh and JSON name is try-mesh. Yeah. There may be some other places here that I need to change, but let's start with that. Start with that and let's see what happens. And this might just completely crash the asset browser now. Let's see what happens. Might also just work, which is what I'm hoping for, of course. So development blueprints, dynamic 1, and now we should be able to do try-mesh. Look at that. And now we can do concave object. Materials default. All of that should be good. Let's save that and oh no, blueprint data error. Blueprint data error. What? Why is it erroring on me? That's interesting. Like if we take let's just see what the differences are here. So we have the static one on that side, and then we have the dynamic one on this side. What do we have? Yeah, so we have essentially like exactly the changes that we're expecting. The name, the type, mass, dynamic true, and block out brick, yeah. Yeah, that looks completely fine. I don't know why it thinks it has a blueprint data error. That's a bit strange. But it probably has to do with the C++ side. That's what I'm guessing. So if we go to core engine, shut down most of these things, and we go to physics API, rigid body description. It's actually it's shape description, isn't it? Shape description is here. Or is it? Dynamic body transform component. This guy needs to be able to support the try-mesh as well. I was hoping it wouldn't really require me to have any do any changes on this. Physics transform component, shape description from JSON. Ah, that doesn't look good. Try-mesh path, don't care. That doesn't look good. Try-mesh path, don't care. So if it is tri-mesh, it gets it out of there, yeah. Okay. Yeah. Okay. Dynamic body transform blueprint properties. Tri-mesh shapes not supported, I guess it should be. Tri-mesh shapes not supported for dynamic objects. That would be why. That would be why. Okay. So then we go to basis static body transform component. There we go. And we look at this. Tri-mesh resource paths. Yeah. Okay. Yeah, okay. So when we read those paths out of the blueprint, and this is a blueprint, by the way, in the terminology of basis, we need to store this object or this file path. This resource path is actually what it's called. This resource path somewhere. The static object does it, but the dynamic one doesn't do it yet. And that's why we get the error there. So what we need to do is we need to go here into static body transform blueprint properties and copy this into, it goes under the material names, yep. Like so. And then we need to essentially, yeah, we need to get rid of that don't care stuff. Tri-mesh path don't care. Take that away. And instead we do, what was it called? Tri-mesh resource paths. So that would be just 0. This would be I. And then we can take this thing away. Shape type tri-mesh. Now, it would be nice, of course, if we could detect that, hey, someone is trying to use a triangle mesh on a dynamic object, but the tri-mesh doesn't have SDF data. But I think that is something that we need to do somehow at runtime. So here in the static body transform component, we are actually asserting that we have physics mesh data. Has physics mesh. So you know, it might be nice to have something like has physics SDF and so on. Mesh resource, yeah, okay. Yeah, that would be handy to have, but we're not gonna do that now because that actually requires me to change the data format for the mesh resources. So for now, let's not do that, but we need to take this and essentially copy it. Create physics objects in static body. We need to take this part and copy it to the dynamic body as well. See, do we have a similarly named function here? We do. Good. Good, good. Yeah, let's compare these two as well. Text compare. We put the static one on the left and the dynamic one on the right. And we see what we have. So yeah, they're almost the same. We have an additional assert here, which may be handy, and I think we should probably take that as well. And then we have this try mesh case, and then the dynamic one has this check here: vehicle wheel shapes must be exclusive. I think this is like a requirement by PhysX itself, and so that's why I do that. We'll just copy all of this over. So if blueprint properties shape descriptions, all right. Yep, all right. So we need to include the basis mesh resource, and then we have this try meshes, which is probably just a pointer or a double pointer, perhaps is what it is going to be. Yeah, it's a double pointer to, so essentially a pointer to a potential array, and the reason why it's done like that is that the majority of these transform components won't be try meshes. They would be something more simple. And so in the case that we don't actually need an array of try meshes, which is going to be the majority, it is just a simple pointer, or in this case a double pointer, which takes up almost no space at all. But here we go. If we don't have it, then we create a new array. We create like a new array on the stack, on the heap, and then we create try mesh using the data, so we don't cook anything anymore here. It's completely fine. Set the try meshes there, and then we need to free them later on. So destroy physics objects. Yep. So in between here. Pointed to incomplete class. Okay, physics API try mesh. Like so. And then of course we want to destroy the entire array, like so. Delete array. There we go. So now we will see if it actually works. Lawrence, or is it Loan maybe, says, hey. Well, hey to you. Welcome, welcome. I'm wondering, is Madrigal doing this full-time, or does he have another full-time job? I'm not doing it full-time, I'm doing it part-time, so to speak. And by that I mean I am I'm working almost as if this was full-time, but I'm doing it sort of in bursts. Unfortunately, it's not my full-time job, at least yet, because I don't really get paid for doing this yet until I actually ship something. Alright, let's see. PhysX assertion failed. PhysX invalid parameter. As that shape, non-SDF triangle mesh. Oh. Yeah. So why is this a non-SDF triangle mesh now then? So this is what we would expect to happen if we don't actually generate SDF data. Right. But as far as I know, and I may be mistaken, as far as I know, the thing is supposed to have, oh, it's not that, it's the concave object. Yeah, look at that, we have marked it as having SDF data. That's interesting. Well, let's convert it one more time. Generating physics SDF data. Yeah, it's clearly not. It's clearly not of the opinion that we do have SDF data there. So that's a little annoying. Let's take all of this and copy it somewhere. Probably into like one of these tabs here. NP rigid body template. Should just really be able to search for that, right? Oh, it's actually in an H file, so let's add star.h. Thanks for the info. Can I ask where you're currently working? If you mean my other place when I'm not doing Madrigal stuff. What? This is SimJom. Right, so I think this is where it probably fails, is it? So it is a simulation geometry. If it is not a plane, and it is not a height field, and it is not a tetrahedron mesh, and it is not a triangle mesh, or it is a dynamic mesh. Right, so here we go. That's the thing. Is a dynamic mesh. If we have a get SDF data fast .sdf is not null, right? This probably returns false. And then this will be, so we are a triangle mesh, but this is not marked as a dynamic mesh. Is that how I'm supposed to read this? Right. Yeah, sorry. You asked where I'm working. I haven't really spoken about that like a whole lot publicly. I think you can probably find that out just by looking up my name, which you can find on the Madrigal Games website. Kind of try to keep the Madrigal stuff and my other professional stuff sort of separate. But I work as an engine programmer at a large game studio, doing projects that are significantly larger than this. And my work over there has really nothing Nothing to do with this stuff because I'm really just doing tech work over there. It's not a secret or anything like that, but it's so different that it doesn't really necessarily have anything to do with this. But like I said, you can figure that out if you want to, and several of my viewers have done that. And I should say they're very gracefully allowed me to work on this stuff even in a commercial capacity, so very grateful for that. Okay, let's see. I think what the problem is here that we are not we're writing the SDF spacing here. Let's see. Serial try mesh data in the converter here. You're setting the SDF spacing to something larger than 0, so we're seeing this output, right? And then we're passing it to serialized try-mesh data, so it comes out here. And then we're passing it to the back end, and that would go to here, SDF spacing. But then we are not actually passing it onwards. Yes. There we go. That should fix the issue. That should fix the issue, shouldn't it? Pretty sure it should. Let's copy those into tools. And now if we go here and we open this again, still the same issue. Oh, okay, but that's because we still need to do the conversion. We can do the conversion directly from Windows Explorer. I have like an integration here, so that would be game. No, it's not game. It's objects, debug, concave object, and basis convert. And that should again give us the SDF data, and it gives us the path. That's good. So now then, fingers crossed. Fingers crossed. Hey, no assert. So this is now ostensibly a dynamic object. Let's try it out in the game. Exciting. And you know what this means? If this works, then we can move on to working on that vehicle that I showed you. I'm probably getting ahead of myself here because we haven't tried this yet, but it should be exactly that. So, it's falling through the ground. That's not good. Why is it falling through the ground? Oh, it's falling. Oh. Yeah. It's probably falling through the ground because we can't do it here. We need to use this special version of this now. We need to set this to some sensible material, at least, probably. Default should be pretty good though, I think, shouldn't it? Maybe not. Let's set it to like vehicle chassis for now. I think we're gonna go with that for now, and then I'll do a concave test layer, and we'll move those to the concave test layer, and then we'll reload this. There we go. Okay, so it's colliding with other meshes, but it's not colliding with the ground. That's That's a bit unfortunate. Does seem to be like that's probably just a configuration thing. Hey, look at that. Concave collisions. Isn't that nice? What if we add some odd objects on top of that then? What am I looking for? Dynamic props, probably. That's probably what I'm looking for. Yeah, that looks good. That looks good, you guys. Cool. So the only thing that's not working is the collision against the ground. I bet that's some sort of filtering issue on the physics side. Right. Oh, did I leave that box there? Yeah, I did. Because it's on the wrong layer. Yeah, okay. But yeah, that doesn't work. That just falls through the earth. Let's try this in game and see if it's different in game. Because the physics simulation in the editor is a little bit special because you can simulate only like a certain number of objects and things like that. All right, and we need to make it auto load. Except it might of course be kind of interesting to not load it and load it when we are right next to that place. Can I is it game state maybe? I'm trying to remember if I have a command here for loading a layer. Might not be. Yeah, I would have to add a script to it, but let's just set it to auto load for the time being. Yeah, so it does fall down and then it will get destroyed eventually when it hits like the kill plane. Or not. There might of course be like an issue with that as well, right? That like collisions that otherwise would work, they actually don't work. Let's get a gripper here and let's see if we can we grip these guys? This is gonna be super tricky now because they're kind of wonkily. Well, first of all, can we collide with it? Yes, we can collide with them. Okay, good. It might, of course, just be that I am unlucky and height field shapes don't collide with SDF shapes. If I'm being really unlucky here, you can see a bloop, it just falls through. So if that is the case, then I'm in a little bit of a pickle here because my terrains are height fields. and so I kind of need that to work. But let's not panic yet. Can actually grab that thing. Come on. Can't quite fit there for some reason. Okay, let's make it a little easier for us to test this out. So I'm gonna add a primitive geometry object. Let's make that 5 and move it here. Then we can like reset that thing. Make it a bit easier here to mess with this. Oh, we need to make it. Oh, it is a physics blocker, so that should be fine. And then we're gonna add a gripper here, which is sort of nicely oriented already to be facing that way. Something like that, right? Let's add those to the correct layer as well. Okay, so now then, open the gripper arm, move it down, something like that, and then drive a bit forward, handbrake, enable. Will this work? Yay! Yeah, so that works at least somewhat. It's a little wonky, but everything with this vehicle is a bit wonky. So there's really no surprise there. And we can collide it against. Nope, that works. We can collide it against rocks and trees and other things. Just lifting the rear wheels into the air because it's so front heavy now with this thing. Yeah. Alright, well, it works well, except for the fact that they're falling through the ground. I do wonder if that just has to do with the fact that this is a height field. Blip. And off it goes. Let's do physx SDF height field collisions. Because of course we now have that set to there we have the custom version. We now have it set to material vehicle chassis. And the vehicle chassis actually collides with, yeah, it does collide with the ground. It doesn't collide with the wheels, but it collides with the ground. That should be fine. Yeah, if anyone knows if SDF meshes and height fields can be made to collide or not, let me know. Doesn't seem to say anything about that here. And that is, of course, a little bit of an issue for me, because like probably around 80% of my levels are actually just terrain. Let's do one thing. Let's actually run this in debug mode. Before we do that, I'm gonna want to export this, so we don't have to run the editor in debug mode. Let's export this so that we can run it directly from the game, like so, and shut that down. And then we do debug, and let's hope we don't have to rebuild the entire engine in debug, but remains to be seen. Sometimes when you are doing things like this, something doesn't seem to happen or work or register or collide or whatever in physics, then you run it in debug mode and you get like an assert failure that this is not supported, which can be a little annoying, but at least it might tell you what the problem is. So that succeeded, and let's make sure we're booting directly into the level. Let's not do D2D12 currently, and let's run this thing, because if this actually doesn't work, then I think I might have to do that that truck bed as manually decomposed convex hulls after all. Oh, this is slow. Wow, why is it this slow? That's not good. Okay, let's fly through the cliff once again. Oh, come on. There we go. So, just grab this guy. There's something going on the physics side. It's really, really slow. I think the SDF stuff might just be like super, super, super slow in debug mode, right? Because as soon as I got close to that object, it just became very slow. Yeah, oh, very, very slow. Okay, let's just back away and then open the thing. Right, so we don't get any assert failures at least. Up, there we go. What is this? Assert failed. Not supported. Overlap function. overlap function table. That's interesting. Search for that. So it doesn't find an overlap probably between. Well, that would explain why it doesn't work then. But it's probably like it is probably the kill plane that it doesn't find it for, right? Get overlap function table. Okay. Can I not actually find that table itself? Geom overlap method table. Okay. So we have sphere, sphere plane, sphere mesh, sphere height field. Okay. So we're essentially interested in the height field. So plane against height field is not supported. Plane against triangle mesh is not supported, but that's probably what we saw, right? Height field against capsule, height field against box, height field against convex. What? Height field against convex? That should be supported. I don't know what that means. Convex mesh. Tetrahedron mesh, triangle mesh. Triangle mesh against height field, if that is how I'm supposed to actually read this. Triangle mesh against height field is not supported. Height field against height field is not supported. Height field against triangle mesh is 0. Okay. Okay, well that's annoying. That's annoying. So we have a few options here, as far as I see this. The reason I would like to have SDF dynamic triangle meshes is that super jittery for some reason. Yeah, the reason I would like to have those SDF dynamic triangle meshes is for this. And so if we made this bed, truck bed here, an SDF triangle mesh, we can make it dynamic and it could still contain objects and all of that good stuff. But then if we flip this thing upside down like this and it falls onto the ground, then the bed won't actually collide with the ground, right? And that's a bit silly. Or rather over here where we have height field terrain, it just look like this. That's a bit stupid. So what we could do, if we really wanted to pursue this, would be to have this bed still be one of those dynamic SDF meshes, but then have a separate one, which would be just a box, which would collide with just height field, and that would work. But how much better is that than just simply making that out of those convex hull objects? Probably not much better. Well, that's a bit of an issue, isn't it? I was kind of hoping that if I made this work, that I could actually convert the mother vehicle to use triangle mesh as well, but that clearly isn't gonna work if SDF triangle meshes don't collide against height fields. So that's a bit of an oopsie. It's a bit of an oopsie doodle. Okay. Tell you what, I'm gonna go make myself a cup of tea, and then I'm going to start working on this truck bed anyway, because there's like a whole bunch of stuff that we can do, which will be the same regardless of how the collisions will work. And I think, like, for now I might just want to do them as a set of convex meshes. Yeah. But that means that we will get to do a little bit of gameplay programming in Zig, which is always fun. And then I can still keep the stuff we did today around. It's nothing really wrong with that. Maybe I can benefit from it somehow, but I don't think it will solve this issue that I was hoping it would. Anyway, let's delete this layer here, like so, and I will go make myself a cup of tea, and I will be back in about probably 10 or 15 minutes. I'll put up one of my quick break visuals for you guys, and so we'll continue doing a little bit of gameplay programming after that. If you need to run in the meantime, I thank you for your time today. Thanks for hanging out. Otherwise, I'll see you in a little bit. All right, folks, we are back. We are back, and we will shift our attention now to doing a little bit more gameplay stuff. I think I'm gonna start by just making it very easy for myself to to test out this stuff that we're going to be doing. So let's create a new level here. Call this terrain. Not call anything terrain, but add a terrain. My mind is just elsewhere today. Maybe it doesn't even have to be quite that large. Doesn't really technically matter, I guess, but still. And in the middle of the terrain, we will add one of these vehicles. We're going to be working on, so it would be the gripper truck. Let's actually just add it at the origin, and then we probably need to move it up. It's standing on top of the thing. And so what I of course want to start working on now then is this bed thing here. It has essentially two main things. It needs to have collisions, and we need to be able to tilt it back. That's kind of like the whole point, of course. And then later on, it will also have two sort of openable hatches here at the back. We can actually probably go have a look at the thing in Blender. Gripper truck. Here we go. As we can see that its pivot is already here where it should essentially be rotating. So if we bring in the everything is all right, just in local view. That's why we can't see anything. So we can rotate it, and we will of course rotate it around X. And it should rotate something like this. It doesn't rotate like very much actually. If we rotate it more than this, it will start to just clip through itself. So we don't want that. We want to rotate it about, what is that, 25 degrees or so. And then of course, if that is not enough, if we need to rotate it more, then I will need to modify the shape probably of this back a little bit here. If that is like, you know, not enough to make things fall out of it. But I'm hoping that it will. Actually, what is the absolute maximum we can rotate it now? Until it starts to like seriously clip through itself. Is it already clipping? It's clipping a little bit, isn't it? Very difficult to see actually. It's actually not clipping yet, except here on the inside. But that's not really all that big of a problem. Yeah, we can rotate it. Let's say 32 degrees. Yeah. 32 degrees is probably good. And then we will also probably have some sort of actuator here later on. But I haven't even modeled that. I just created like a place for it here. But that's good. Okay, so 32 degrees. I'm actually gonna just write that down here. And then we have the hatches. I'm pretty sure I had the hatches here, but yeah, so there's a gripper arm which is supposed to look something like this, which has like the gripper here in the front, and then it can kind of, you know, grip something and sort of throw it there like that in the back. That's sort of the idea. Wheels look something like that. Now where are the hatches? I'm almost certain I had the hatches there at some point. GTMC4, what is that? Right, these are just the... okay, yeah. The gripper truck main collisions. Yeah. Yeah, so here's the body sort of decomposed into these shapes, and they need to be convex, and we need to do basically the same with the bed. But the bed can be, I think, perhaps doesn't even require this many or this detailed, because it's basically like a box already. So that's probably fine. Where are those hatches though? It's very strange. Well, I don't know is the answer. But anyway, we have the 32 degrees, and we have this object which is which has its pivot around the place where it's supposed to rotate, so that's a good start. Let's create a script here. Just a normal script. And when the normal script, actually when the game started message arrives, set single player avatar to level objects base gripper truck 1, and let's save this to test levels and do like truck bed work level or something like that. So when the level loads, we get sort of assigned this as our vehicle, and I think I want to create another layer here, which we'll call cargo. And on the cargo layer, we will add some of these dynamic props. So let's have like one of those. Those fit into the thing, right? Yeah, just about. I don't think I tried to make it match that, but it seems like it's almost doing that. And then maybe a couple of these guys. Like that. The cargo layer won't be loaded immediately, but we will instead just take some of those away here. And we'll add a function called load cargo. Load cargo. Self load layer. Layer name and blocking. Doesn't it block? That's called cargo, like so. So now if we play this, we have this vehicle, and we should be able to easily sort of. My mouse is very fast for some reason. Should be able to easily load the cargo into it by just running the script. Boom, and you can see that yeah, it doesn't actually work currently. They just fall through the thing. as expected. But that's fine. And now what we can do is we can export this guy, export, and we can just shut down the whole editor. Get the path here to the test level struck bed work. And then let's go here to our Zig gameplay solution and add to launch. Play level, and we add that there. So now we just run it from here. It should boot directly into the level. And here we go. And we can see that even with just like 3 of those boxes, you can actually see it probably better if we position the camera slightly differently when we load that cargo. Now it's looking pretty good. But now if we load the cargo, it's just pressed down a lot, so I think probably might want to give more strength to the like rear springs, if that makes sense. But okay. So now we have a pretty good way to actually test this out. And what I was thinking we would do is sort of use the same way I did with the mother vehicle's crane here. So mother vehicle has this crane, which is made up of well, a number. It's actually a variable number of dynamic objects. But the interesting thing here is that like this thing moves independently from the rest of the vehicle, but it still has collisions. So in that sense, it is similar to the bed. And I think we should be able to use the same sort of physics setup as we do for the arm there. And yeah, of course, the arm doesn't collide with the bed because the bed doesn't have any collisions, but it does collide with the actual green parts of the vehicle there. So that should be good. And the way the arm is made is by adding some dynamic objects to the main sort of, well, I think it is actually like a set of separate actors actually, and they are connected to the main actor with a special spring. So let's have a look here. If we go to 2-joint crane arm and look at what this thing has. So it has an arm physics part. An arm physics part has an actor and a joint. And then an inverse joint actor A transform. I don't remember what it's used for, but it's used for something. Right, it's used for the inverse kinematics of the arm. Well, we don't have to care about any of that because we're not doing any inverse kinematics with the bed. But the rest of it will be mostly the same. So if we look at the joint, for example, we create a 6° of freedom joint. We actually enable projection. This doesn't do anything anymore in physics 5, so we can leave those out. And then we can sort of we can enable and disable certain parts, certain motions for that joint. And with the bed, we will essentially disable everything except the rotation around the axle that holds the bed in place. If that makes sense. I still might want to do it with a 6 degree of freedom motion joint though, because they're kind of easy to drive. If I remember correctly. Don't actually remember exactly how I drive these. So we had this inverse joint actor A transform. Set drive goal pose. Right, exactly. Yeah, so we set the pose that we want it to be in, and that has to be calculated somehow. And I don't remember exactly how those spaces went, but it's just a single rotation, so it should be pretty easy, I bet. Let's take a look at that function. Okay, only the 6 degree of freedom joint supports drives at the moment. Well, if we don't want to actually improve that, we're gonna have to use a DOF 6. Oh, I actually have the game running here. Shut that down. Just shut it down like that. Or am I actually debugging it? I'm probably debugging it, that's why it doesn't want to shut down. There we go. Asset browser we can leave open. All right. Set drive position. Yeah. Yeah, you're just basically telling it, hey, I want you to be here. Would you please move there, right? Just trying to understand my math here from about a year ago or so. We have this graph. This is probably a C node. Yeah, this is C node pointer, so it's basically like the root node of a graph that we are setting up. And this is all way more complicated than the bed will be. Well, I'm just trying to understand the drive mechanism here. But essentially, we're setting the orientation here for the graph, and then we're getting out of the graph. We're getting that bones local to ancestor transform. So local to. Right, okay, it's not the parent, it's the ancestor, so we give it the graph parent, and we get like a bone 0 to vehicle matrix out of that. So from bone 0 to vehicle, local space. Yep. Because this graph parent will be the vehicle, most likely. And then take that, and we concatenate it with inverse joint actor A. So joint actor A is probably like the actor that the joint drives, and joint actor B is the actor that the joint is connected to. So the inverse of that transform. And that gives us the drive goal matrix. This was probably very, very obvious when I wrote it, but now I'm like, what? Well, that's how these things always go. Okay, well, I'm sure we can figure this out. Obviously, like, yeah, we're not actually even updating that. Inverse joint actor A transform is just used when we are actually setting that up. Okay, yeah, okay. Yes, okay. It's starting to come back to me now. So we're creating a joint. We need to give it an actor A and an actor A transform, and then an actor B and an actor B transform. And what we're storing here is essentially the inverse of this actor A transform as it was when we created the joint. Yeah. Okay. All right. Well, it will take some figuring out to remember how all of this works. But I think still, basically all of this is stuff that we can sort of use and look at to figure out how to make that bed be collidable and rotatable, tiltable, essentially. And so let's move that out of the way. And let's create another of those components. So where is actually, it's here, vehicles. Okay, so let's create like a, what do we call this, like a truck bed component or something. We can actually just call it gripper. And let's call it truck bed component. That's probably fine. And it doesn't actually need to even be here. You can just go directly into the game object components folder here. Like that. Yeah, it's been a while since I've created any new game object components. Probably like 3 or 4 months. See if I can remember how this works. Immediately, I'm thinking that we might want to have want the ability to read input here. And if we do that, we don't want our context to be game object component. We want it to be avatar tracking component. And so if we look at cargo crane component, for example, yeah, this is using avatar tracking component. And if you're doing that, then you can just read input straight from the component itself. Because the avatar is, of course, that's the object that represents a player in the game. And so an avatar tracking component, as the name suggests, tracks which object is which player's avatar. So there's a whole sort of like multiplayer idea that we might have multiple players controlling their own game object, and then the avatar tracking components know who they belong to, and they can sort of pipe the input directly to the component and all of that. So it's very handy in that sense. All right. Then I'm gonna want to take some forward declarations or whatever we call those here. Physics scene, shape pointer, actor pointer, joint. Yeah, I think we need probably all of those. I bet. The cargo crane component actually sort of splits out some of the logic into other types. So it has like a 2-joint crane arm, which is the arm itself, and then it has the crane cable magnet assembly. So 2-joint crane arm. If we have a look at that here again, this thing then creates. Does this do any networking? Does this do any sort of propagated values or anything like that? Doesn't necessarily. Yes, it does. Steering values. Okay. Which is just packed into a vector tree, so rotation around root, vertical distance, and horizontal distance. With this, we essentially only really need a single float, at least currently. Single float would be the rotation, but I think eventually we will want to have those hatches there. So these things here, and I'm thoroughly confused why I can't find them there in the Blender file, but I might have to look it through my version control if I somehow deleted them. It's sort of like a piece of the wall that kind of rotates out like this. And then there's a similar thing on the other side. So maybe we'll at least maybe we want to have a steering values thing here as well, where it doesn't necessarily need to be a vector 3, it can be vector 2, where like X is the rotation for the, the tilt for the bed, and then Y is like how much to how much you open those hatches from 0 to 1 or something like that. And then those need to be their own physics parts as well. So there will be a little bit of a graph here as well, actually, with this one, because obviously the bed will be nested to the vehicle, and then those hatches will be nested to the bed. So there's like a 2-level graph of transforms. So that might be something to look at if we want to have a similar sort of graph of nodes here that we can then use to figure out those transforms. What do we have here? Server only parent node. Right. So on the server we actually create a parent node, but on the client it's just attached to the render objects. The client, the server only parent node is supposed to be null, on the server non-null. Yeah, on the server we create one XTC node which is moved around with the parent object. On the client we attach the root node to the render node of the transform component. And that's handy because it handles all like interpolation and stuff like that you need to have smooth visuals. All right. That's probably good. And then I think this guy also has, or is it this cargo crane component maybe? Doesn't this have like some blueprint properties? Yes, it does. Cargo crane component properties. Arm end volume sphere index magnet volume sphere. Right, okay, most of these yeah, I have a comment here that I should move these to blueprint properties, but I haven't done that apparently. So arm root position is like, this is the position on the mother vehicle where the crane is. It's currently always in the same place. That's sort of stupid. But yeah, these could be probably almost all of these, if not exactly all of these, could be moved to a blueprint property object. And that means that we can then set them here through these things. Let's go to vehicles. Vehicle blueprints. This is just me like looking at what I did previously and trying to understand it again. I'm sorry if this is a bit rambly, but I need to remember what I did previously to be able to make this new thing. So where do we have the cargo crane? Here we go, cargo crane component. So it just has these few sort of properties here. We could add more there later on. All right. Maybe this is enough to get started. I'm kind of tempted to have this sort of similar kind of graph setup here. Since we have those hatches that would need to be openable. Graph nodes. Yeah. And then, of course, the gripper truck currently has the bed here, which we should probably just take away. What do we have? So we have this is the dynamic body transfer component. It just lays out a whole bunch of convex hull things, as well as the cylinders for the wheels. That's fine. Then we have the mesh, or meshes. So we have the chassis mesh, we have bed mesh, interior mesh, vehicle controller, and then some helper things here. Okay, so if we take this away, maybe we will actually just disable it from all of the various places here. Mesh component create call on the server. That's not good. That's probably a bug actually. If you have nothing, yeah, okay, that's a bug. If you just remove it from everywhere, it kind of assumes it is going to be created everywhere. Right, so this is what we actually want to start with. And the place where that bed is supposed to be fastened is in here between these two, what do you call those, like bolts. So this will be the place in the local space of the vehicle where we attach the thing. So as a very first thing that we can do here, let's actually let's create a blueprint properties object for ourselves, sort of one thing at a time. And how do I do that? Well, I create a member here. Ah, Jesus. I'm starting to lose my voice a little bit again. Let's hope it goes away. I create a member here called blueprint properties, and we can call that truck bed component properties. We don't have that, of course, yet. So let's create it, and I'm just going to copy paste this here from another one. Truck bed component properties, like so. And this guy should have, let's call it fixed fixture position, and it's a vec3. For sure we're gonna need that, so let's do const vec3 is basis math vec3. So vec3 is 0, and then the props, this should be what should it be? It should be probably it should have the same name, and it should be a F32 F32 is supposed to be a slice, maybe. I'm gonna have to look at this. Let's see, let's search for that. We can find one which has that's cargo crane, didn't have. So I'm looking for one that has a vector 3 in one of its yeah, so here we go, switch market position. And yes, it's an array of F32s in the JSON data for that component, so that's good. Fixture position, and then we quite simply just do copy that over. And you might be wondering why do we need to have this in two places? Well, if we use the standard JSON parsing, then the vector trees will be arrays of floating point numbers in the JSON data, and that's what this thing will actually give us. But then, and this is actually what I want to do, I want to convert it into a vector tree, which the object can then use, rather than just having it as an array of numbers. Like so. And that's really everything we need to do now. To be able to actually see that in the tool there, we need to go back to where we were previously. And what does this means vehicle component? So you can copy that, and we can add one of these UI definitions. We'll call this truck bed component. And we can edit it, yes. So truck bed component, and we need to match the name to this name here. So means.truck bed component. Truck bed, and it's supported basically everywhere, I think, at least for the time being. Switch market position is a vector 3, so we can take that and just delete everything else for now. But we call this instead the fixture position. And then we give it a description. The position in local space of the vehicle where the truck bed is fastened. Perhaps more importantly, the position which it rotates around, but I think this will be good enough. And default can be 0. It's completely fine. Yeah. So that's that. And then I think the first thing that we will want to do is quite simply just draw that. So let's do basis, debug draw, and draw maybe like a sphere. And we'll do self dot blueprint properties, fixture position. Radius can be 1, and color, basis, color, orange. Like so. Take those away like that. Yeah, I'm really just rediscovering my whole gameplay system here. Been so long since I did any of this, but it's good. It's good to be reminded. Now we need to import the thing, so we'll call this truckbed.zig. I'm gonna make it available here publicly as truckbed component, and then we still need to register it here with the rest of the components. And now if we build this debug, it should hopefully build. And it did. So what if we go to build.zig now? Yes. So I'm building in debug configuration because it's much faster to build in that. Still using it with the release version of the engine. Cool. So truckbed component that should now be registered. We still need to throw one of these guys onto the gripper truck. So let's do that. Let's see. Yeah, I reloaded the UI definition. So now if we go here, I should be able to find it in the list, I think. Truck bed component is right there. Okay. And we want it essentially everywhere. That's fine. If we draw this now, we can see that our our orange sphere is there in the middle. We can take those other things away. So now I want to position it there a bit backwards and a bit upwards. Actually, let's make that smaller because it's so large that I can't even really see what I'm doing. There we go. So maybe like 0.2. Keep opening that Visual Studio even though I don't want it. Alright, so now it should be easier to see where we are. Or in a little bit. Now we're just inside of the thing. That's clearly not correct. Let's make that 5. It's probably too high. Yeah, it's way too high. So 1 is starting to look pretty good. And now we can just move it backwards, maybe -4. It's almost correct, but not quite correct. 3.8 and 1.2. That's pretty spot on actually. Unfortunately, I don't have what's it called? An orthographic projection view here in this. It would be really handy in some cases to have an orthographic projection, because now it's kind of like I have to like in perspective mode go like is it there? I think it's pretty much there. So we can live with that. But it would be nice to have an orthographic projection and then just be able to look at this almost as like a blueprint. Not in this blueprint sense, but like a blueprint on paper. And that would be nice. Alright, so now we have the thing in the correct place. That's neat. The first thing that we can do now in the component is to actually add back that that mesh of ours. Oh, hey Sebastian, welcome back. It's been a while. It's been a little while. Cool looking tooling on this thing. Yeah, it gets the job done. It can be a little clunky, but it gets the job done. That's kind of important part here. Rightio. So one other thing that we can perhaps do almost immediately is, if we look at the cargo crane component here, actually it's not even that, it's probably the almost a 2-joint crane arm. Now it's actually probably the cargo crane. Yes, okay. So this guy has some meshes. Oh, these are actually not even visual things, right? Yeah, they're not. Okay. Did I manage to finish the web as a mods plugins? Yes, I did. I did. Or, well, is anything ever finished? But actually, I'll show you in a little bit. Yeah, I made something that I think is pretty cool, but I'll show you in a little bit. I'll finish this one thought that I had. I wanna check something here on the mother vehicle. So the mother vehicle has the crane. The crane is not visible here, and that is probably because we are creating it from code. But we don't necessarily need to create it from code, I think. Instead, what we can do, and this is not something that was all that easy to do back when I did the crane, is we can just add a normal mesh component there, and then we can use it from our code. I may not be explaining this very well. Let's see. See if we can find, is there any bin mesh stuff here? Yes. So we have some bin mesh things. How do I do in Visual Studio, like, please show me the whole thing? I don't want to drag it off screen. And now I can do, okay, there we go. So with the mother vehicle crane, what I actually do is I have like crane arm base bin mesh, crane arm bone 0, crane arm bone 1, and then their materials like this. And again, I have a comment here that I should put them in the parameters so they can be overridden. We don't really need to do that necessarily. What we can do instead is just go back here to the gripper truck and actually find the truck bed mesh. Here we go. Bed mesh is the name of it. We can enable it again here in this. And that should be fine. Oh, you know what we can do actually about this? I'm just realizing so much now at the same time here. I'm gonna have to explain everything. We can get this position from Blender actually, and just convert it quickly into basis coordinates. That's how we get the center of this. That's what we're going to do. Anyway, that was a tangent on top of the tangent. We can just get this bed mesh name, and then we have this component here, the truck bed component that we just created. We just have it go like, hey, get me the mesh with the name bed mesh, which is this guy, and then start actually poking at that, right? That way we don't have to really do anything other than, like, you know, get a hold of that mesh and start moving it around. And so to do that, what we want to do here is nothing is ever finished. Indeed, it's just abandoned or shipped. Don't want to interrupt. No, it's no problem at all. I'm doing gameplay programming again for the first time in ages, and I'm just I'm just rediscovering everything here. So I'm a bit I don't know, distracted. It's no problem. Feel free to ask questions. I'll get to them maybe not absolutely immediately, but I'll try to read the chat every now and then, and I'll show you those mod things in a little while. Right, so we want to put a string here into the properties. So let's go back to this, and we can probably find some strings here. Yes. So here we have vehicle description path, for example. We can use that sort of thing. So we're gonna call this bed mesh component name, and that would be a basis string. And we need to actually have an init and a dinit here now, because string does allocate. Right? Bed mesh component name equals basis string init and allocator. And then we need to deinitialize bed mesh component name. And here it's really just an array of U8s. So same thing here. Like so. And how do we actually assign that then? Yeah, okay. Just try set. That's fine. So try self dot bed mesh component name set and props bed mesh component name. That looks good. And then we need to add it to the UI definition. Let's see, do we have a string here somewhere? If we go to the metadata thing and we do means vehicle, wasn't it means vehicle? Where did I copy this from? Means vehicle component. Vehicle description path. Oh, these are actually not strings. They're resource paths, but they're just strings at runtime. Yeah, what I can do instead is like look at the documentation here, and we can see string. I think string is one of the types. Is it not? Pretty sure it is, but let's see. Something like that, right? Wow. Well, I'm just going to try it. I'm pretty sure that's going to work, so I'm just going to try it. Go back to, where was it? Basis. Here we go. Truck bed component. And we call this the bed mesh component name. I should just be able to add a string there. Default is nothing. The name of it's like the short name of the bed mesh component. Right. Something like that. And with a little bit of luck, that should now work. Right, I probably need to reload that thing. Yes, so now we have a text field here, so it did work. Yeah, you can see some of this UI is like a little slow. You just scroll here and you get this like repeated fields. That's just like, it's just WinForms. It's old and crummy. But okay, now we said bed mesh here. So the idea here is that we have a bunch of meshes. The name, also known as the short name here, is bed mesh for the mesh component that adds the bed there to the back. And we tell this truck bed component, which crucially is like below the bed mesh component in the list, which means that this guy gets created after the bed mesh. We tell it that, hey, you have a sibling component called bed mesh, and that is the bed mesh component that we want you to start, rotating as we tilt the bed and all of that. That's kind of the idea here. So my other epiphany here was, of course, the fact that the fixture position we can figure out from the Blender file. Let's go here. And we go to... I mean, it does look like it is in the right position now. Yeah, you can see even here we have the bolts and the pivot for the object. So if we go cursor to selected, it jumps there, and this should now give us the position in the local space of the thing, right? So x is 0, y, which is our minus 0, minus z, is 3.8. Actually, it's even more precise than that. So minus c would be, yeah, well, we're actually pretty close. Minus 3.8, it's 3.81755. And then it's 1.2, blah blah blah. So I was actually pretty close already. There we go. Oh. Yeah. I added that to the clicked it again. Yeah, exit, that's fine. I need to rebuild the component now. Rebuild the game essentially. Because we were telling the asset browser to put this bed mesh component name thing here, but we hadn't actually added it here to this props thing. Like that. Okay, and now then. There we go. There we go. Okay. All right. Maybe it's time to look at the mod stuff here in between. So last time Sebastian was in the stream, I was just about to get something usable out of my WASM mod support thingy, which allows me to run mods in WebAssembly format. And I have gotten to the point now where I think my next pre-alpha build will have mod support, and I created like a very quick and dirty. This needs a little bit of cleanup, but it's basically ready to ship. A very small mod which adds a jetpack to one of the cars in the game. So let's just actually run the game, and I can show you what I have. Oh, this is a boring level. Let's go to one of the more interesting ones, right? So let's use the depot level, for example. So we now have a mods manager here, and we can see, okay, we have a mod. It's called Flying Scout. We can check some information about it, and we can see that, okay, it has a library type is WASM, which means that this is sandboxed. And it's enabled and it's loaded and it's all ready to go. If you want to, you can also allow unsandboxed mods, and that means that you can just compile your mod into a DLL, and then of course it can essentially do anything. Which is why I don't allow that by default. You have to sort of set this to true here, and then native mods can be allowed to run. We have the mod folder here, which we can go and have a look at. I should probably just add a button to jump directly to this from the mod manager. It's called trampoline, but it will in the end be called traction point. Trampoline is just a launcher for the game. So we have Flying Scout. We can see that it has a WASM file. So WebAssembly module. It has a BP4 file. That's a resource pack for some data essentially, and then it has a mod.json file. So this basically just gives us the stuff that we can see if we just click info here. This mod adds a Flying Scout game object type called vehicles Flying Scout. And what it also does is it just allows you to place these guys directly. So as you can see, it basically just it's a normal Scout. It just adds essentially a mesh and a little bit of logic to the vehicle. So now we can just and then fly around with this, and it's super difficult to actually navigate, because I don't allow the user to really direct the thrust anywhere. So if you want to fly somewhere and actually have some control over what you're doing, you kind of need to like gather speed while you're on the ground, and then you can just start flying. Oh no, we're actually going backwards. Oh no. And yeah, the jetpack doesn't have any collisions. But this can be kind of fun to play around with. Of course, I don't want to turn this into a flight simulator or anything like that, so I don't really have a problem with this being a little bit tricky to fly. Oh shit. Bye bye. It will get destroyed when it hits the kill plane. But yeah, the thing that's kind of cool here is, of course, the fact that that this is all WebAssembly now, and if we look at the code, there's essentially just there's a single component which is called Flying Scout.Scout Jetpack component, and it has a little bit of math. There's a little bit of copy-paste crap here. We have like the main engine thrust, which is just like, you know, get the positions for the engines in world space and add some force. But if you just do that, then like it flies like a balloon that that you've let the air out of. You just have absolutely no control at all. So I apply a little bit of like force to keep the vehicle upright, so to speak. But that also means that it will sort of level out almost like as a helicopter over time, which also means that it will slow down over time. So it's a little tricky to fly, but it's kind of what I want. This is sort of like the main code for the entire mod. And then I have another, which is like the thruster flame, which adds those thrusters or the flames under the thrusters, depending on how much you actually give it thrust. A little bit of like moving. What do we do here? We're moving some of the meshes downwards a little bit, if I remember correctly. Yeah, set position. So flame scene node. It has a couple of those flame instances, and then it sets like the, let's see, what is this? That's the init. Update flame visibility. Right, okay, yeah, it actually attaches like three meshes to those instances, and then it just sets some of them to be visible or not. And that is how we get that flame that looks like it is sort of flickering between a few of those different versions. And now we're flying away from our trusty car there. Presumably for now we're limited to using game assets, right? I assume there's no pack file tool for modding yet. There is actually. I mean, there is nothing if we're being completely honest here. I haven't released anything yet, but if we go to, not there actually, mods. So here's Flying Scout. There's a build folder which is like the output. You would then take these files and put them in the mod folder, and then the game can run it. But there is a code folder which contains all of the stuff that we just looked at in Visual Studio Code, and there's a data folder. And so what you basically need to be able to package this is like this tools folder, which just contains all of the converters for the game that you're building, and then you need the asset server, which is I just put here in a subfolder. The asset server essentially is the thing that, in the case of mods, allows you to package your data. And then there are some other standard folders. The folders that start with like __ are folders that the system kind of just expects to be there. But some of these, like metadata, well, that's the UI definitions we just looked at, probably wouldn't have to be there because the asset browser is the only one that reads it. Scripts is very important, but it just contains a single pipeline script, so it's very small. Settings is empty. Temp is just a writable folder for the system to be able to write somewhere if it needs to write temporary files. And that's it. And then cache is like, well, it's the cache, so it has some, in this case, some converted textures and whatnot. And then Flying Scout rest, this is all the resources that actually make up the mod. So we have, what do we have? We have a mesh for the actual jetpack. If Blender would be so kind as to start up. It just gets slower and slower with every release. I don't know why. Wow, it's really slow now. This is a tiny Blender file. Well, 1.33 megabytes. There we go. Hello Blender. Right, so we have. Okay, yeah, actually I have the chassis there. But still, it's a pretty small file. So we have the jetpack mesh, and we have these flame meshes. We have like 3 of them on top of each other, like this. And then I just use my standard way of doing materials to generate this diffuse texture here. Then the diffuse texture is exported. So here we have all of the work textures. It gets exported as this. Then we have a blueprints file, and the blueprint is essentially like, this is the Flying Scout. So it is based on the vehicle's Scout object type, and that's why we don't have to like specify any of that. We just go like, yeah, we're defining a new object type. It sort of derives from vehicle's Scout, and it adds a couple of new components. One of them is the Scout jetpack, and the other one is just a standard basis mesh component, which has the Flying Scout jetpack binary mesh, and as a material it has the Scout jetpack binary material, and both of those are found here in this resource pack. Also had some like Merlin effects here that I was kind of trying out to if I wanted to do oh we're missing some, yeah, okay, we're missing some resources here. Okay, never mind then. What is that? This will probably work, right? No, it won't. Oh, it's trying to find the same thing. Yeah, just have some particle billboards here that board BB something rectangle maybe. Can I actually preview it? Thank you very much. No. Seems like I need to restart this if the preview crashes. Homemade tools, everyone. Anyway, this was like an effect that I was kind of trying out for this. It looked kind of alright here, but it didn't really look very good when the vehicle was flying at like high speeds. So instead I went with that mesh-based solution. This sort of stuff. And then when you have your data, you know, ready to go, you quite simply run this batch file and it creates the resource pack for you. So it would put it probably here, right? Yes. You can see that this is now modified. I assumed you weren't going to ship the asset server. Yeah, I mean, asset server is a very small little thing. It doesn't really do anything by itself. You can see the asset server is like, it's like one megs. And a lot of that is probably just like resources. It's not going to be as easy to work with data as it is for me when I have the whole sort of solution and everything is sort of integrated. And some things don't really support. How should I explain this? Like some things I can add quite easily in a resource pack. For example, this Scout Jetpack diffuse PNG thing here is it's kind of easy to add. You just add a new resource pack. You put a texture into it, and then you throw that resource pack into a place where the game can load it, and then it will load it whenever you request that texture to be loaded. It loads the resource pack. Same thing with meshes and you know, materials and a lot of things. But some things like the audio don't really work that way. Like the audio, you would go here into Timbre, which is my audio editor for those of you who haven't seen this before, and here you add actually like you know, one of these events like this, and then the events in here actually reference sound banks, and then you kind of compile this entire project into a form that the engine can play back. All right, so we have all of the UI sounds here, for example, and so then you request these by these paths. So copy path, like a path looks like this, for example, event SFX UI menu button clicked. And so Timbre doesn't currently support, you know, multiple projects. You can't have one project used by the game and then have another project that the mod maker creates, and then you load both of them. That's not possible currently. But I'm thinking of ways to be able to like have like additive Timbre projects. So you would give it, rather than just going like new and creating a new project here, you would go like new additive, and then you would give it the compiled version of the main project, and it would figure out all of these like buses and whatnot, and then you can just create new sounds out of that. That might be something that we can do for modders. But that is why this thing doesn't actually have any sounds currently when you're flying it. There's no sort of a jet burst sound or anything. It's just silent. This is also your tool. Yeah, if you mean the audio thing, yes. Yes, it is also. Yeah, I have a bunch of these node-based things. Like there's the material editor. They all kind of look the same. Sort of based on the same components. So here's like a material editor, which generates the shader code. You can look at the shader code like this. That's how most materials work. Then we have Timbre is the audio system, which you can do a lot of logic in here. Like the engine sound, for example, is just like mixing a whole bunch of different wave files together and speeding them up and down. Then we have Nemo. Nemo is sort of like the scripting solution for missions. So we have the demo mission, which you can actually play in the pre-alpha 1 version. You have like the whole flow of the mission is laid out like this. So you have like intro cutscene has ended, the player drives around the level. We have a bunch of like localizable but still not localized dialogue in here. The player drives around the level, player has entered the lift station, player is looking for power cells, and some other things in here. And you can jump forward for development purposes. You can jump forward in the script through these jump targets and all sorts of things. The elevator is now powered, and then at some point, mission completed. And that's sort of it. And then you can set like these things that I call global variables. It's a term that I inherited from RTC, which this tool is kind of like inspired by. The campaign state currently just has like the current level path, but then the mission elevator has like a bunch of these. Player at station secondary gate, player at mountain path. Has elevator been powered up? Dispenser broke. Those sort of things. Man's got more tools than average live stream views at the moment. Yeah. Yeah. I guess so. You keep them separate for workflow reasons. Yeah, I think it's basically what Matt said, that it's just easier to develop them like one by one. Not all of those things are gonna pan out, obviously, in the end. Like this audio system here was sort of like the this is where I essentially prototyped this execution graph system, which can be pretty handy. Let's see if I can find I have the dev project here. Right, so I have like hits, something like this. It just like there's actually no random here. It just plays those hits one after another. I hope I don't blow your ears out, by the way. Pitch test. We have multiple pieces of music on top of each other, but you can do All kinds of fun things. And then at some point I realized that, hey, this is actually kind of like a scripting solution, right? So if we have a delay here, let's see, what does this do? These are just like test things, test suite, right? So if I start this, you can see that the time just runs there. There's nothing, you know, forces me to have any sort of audio inside of this. And then you have a delay, and then, you know, it even prints finished or cancelled. So if I let it run to the end, after 5 seconds, it will print finished here at the end. But if I run this and then I click cancel, then it writes cancelled. That sort of thing. We have something fun here. Yeah, all sorts of things that I just like. I try to do here. Noise test. Even some like reverbs and things.
Ground control to Major Tom, commencing countdown, engines on. Ground control to Major Tom, commencing countdown, engines on.
But yeah, anyway, at some point I realized that, hey, this is actually kind of a neat scripting solution. So I started using it for the mission scripting, and this is still, it's a little bit, I don't know, it's a little bit of a hack, let's just say. But I also use this for particle systems these days. So we have the smoke pillars for the refinery is made using one of these things. And yeah, you can see some of these like curves that they follow here. There's a really large particle system, so it can be a little tricky to navigate around it here in the editor. But it uses basically the same sort of execution engine, which wasn't really supposed to be used for this. And because of that, it can be a little heavy, a little annoyingly heavy. Like it doesn't. We're still running at 120 locked here, but if you have a lot of these things at the same time, like 400 frames per second now. If you have a lot of these things running at the same time, it can slow down the game a little bit. That's why I'm actually thinking I might want to introduce like a WASM runtime for this thing. Are you using WinForms for the UI? Why not use ImGUI? I'm using both. You can see ImGUI right here. ImGUI is ImGUI is used for like engine runtime things, while WinForms is used for strictly tools. But they are sort of mixed in many ways. I'm just kind of completely losing my voice here. I apologize for that. Let's go to depot here. So I'm using ImGUI for just all kinds of things, and some of these tools that I use here in the editor, for example, they're sort of like game side tools. They might be tools that are used in the editor, but they're like implemented in the game code. So here, for example, I have this grass, and I have a grass editor that you can just use to paint more grass like this, and you can see that it kind of assumes the color of whatever is under under where you're painting. And this stuff is just implemented in imguing like this. So I use everything. I use absolutely everything, and all at the same time. And then you can just go, nope, that was bad. I don't want that. So yeah, I use a lot of stuff. And yeah, this is WinForms. It's mostly just because I know WinForms, but I've had a multi-year plan now to move away from WinForms eventually, but so far it hasn't really materialized. I'm still on it, just because I'm trying to focus on the game. Sound editor was built in large part on streams. There's some old videos you can watch if you want to see that process. Yeah. Was it though? I don't know. I don't know that it was. Maybe it was. I don't exactly remember. The sound system. Yeah, well, I mean, I guess you're right. Some part of the editor might have been written on stream. That's possible. Like the sound system itself is based on SoLoud. So this thing here. This is the runtime library that I use for sound playback, and then this one also has backends, and I use the mini audio library for that. So this thing, and then this thing sits on top of, you know, the platform audio library. So they're like levels upon levels upon levels. But yeah, SoLoud is what actually plays the sound. The reason I'm saying this is that like most of those systems actually use the same runtime. It's just like the audio editor has some audio nodes for you to play around with. While the scripting tool for the mission scripting, for example, just has like a different set of nodes for you to use. Since we're talking about tools, I wonder how you're baking light maps. For my engine, I was considering using Lightmapper H and Lightmapper on Gitmap. Or and oh yeah, this one. Yeah, I've seen this before. It's, yeah, sure. Give it a go. Give it a go. I have a pretty weird Lightmapper. Where I basically use the old school way of rendering the scene from many points of view on the surfaces to bake. Yeah, I do basically the same thing. Actually, maybe we should open a level that has light maps. How about that? Oh, that light map test. That's not what I wanted. But this, I guess this has light maps as well. Yeah, this is perhaps not a very good test, since there's really nothing around this. But like this is the most basic my light mapping ever becomes. So I guess that's kind of interesting in a sense. So if we there's some settings here that aren't really what they should be. Let's go to a level that actually has. It's really none of those. Nope. The refinery. Do you do something fancy for light maps? Certainly not. My light mapper is decidedly unfancy, I should say. And what on earth is going on here? Do not have light maps for some reason. Oh, I probably just disabled them, didn't I? Which makes this baking here kind of pointless. Yep, there we go. Now we have light maps on. Now we have light maps on, and now we should probably rebuild the light probe mesh with the proper ones. Right, so I have two things to do sort of indirect lighting. I have light maps for the static stuff, and I have light probes for dynamic stuff. And dynamic also covers things like these leaves here. Also considered dynamic because they are updating, they are animating, and even some things like this. This is technically a decoration, like small meshes and things like that. Also use light probes, just so that we don't like use up a lot of UV space in the light maps with these small things. But anyway, if we turn off the grass rendering for a bit, and then we can go up here and look at the light map debug view. So this is essentially, you can see some buildings and things here are still not actually finished, so they are also not light mapped. You can see a little bit of the terrain there underneath picking up some of that red. And here's a building that has light mapped geometry, and these are all dynamic objects, so they actually don't appear in the light map. And then we have, like, here you can see this is clearly like an unfinished vehicle, and so it's sort of like shining in there. If you turn off light probes, you can see what like a light probe does to the dynamic objects. They're just way too bright. Look kind of okay if we have everything turned off, if you have both light probes and light maps turned off. But it looks kind of okay. Turn off the selection boxes and we can move this thing around. You can see that it's sort of like kind of nicely and smoothly fits into the environment with the help of light probes. So that's definitely something that you want to have if you have a lot of dynamic objects. You want to have some sort of solution for them as well. Otherwise it's going to look like this. And no one wants this. But yeah, I do basically what you described. I render the scene from all over I render the scene from all over the scene, and I can override certain things here. Like it tries to allocate a large enough piece in the light map for, you know, like a big object like this, but then you can go and bump it up. I bumped this to like 2.2 for this particular building. I see dynamic objects are still affected AO on light mapped objects. Yeah, I have HBAO. So here's the thing without any sort of AO. There's also a built-in AO screen space ambient occlusion, which you can see here, but I actually have it tuned up pretty high on the HBAO path, because I just kind of happen to like the way it looks. But yeah, it works kind of okay. I kind of like the fact that you just get this sort of like bounce lighting almost here. You have this like very sort of yellow orange thing here, you can see that I actually have quite a few of these artifacts here. Like some of these kind of don't have their resolution set as high as they perhaps should. But to be honest, when you turn off the debug view, you just don't really see anything. You can see a little bit here if you're really looking for it now that I mentioned it. But like most of the time, you don't really see anything wrong. And here we have a little bit of red picked up by this thing here in the middle. So it works pretty okay. And yeah, it doesn't. I don't think it will blow anyone's socks off. Just looking at something like this. But then if you turn it off, it's like there's something missing. Or here, if you go here, we have a lot of stuff that's just like there's like a roof on top of something. Just you turn it off and it just looks super flat. Or here underneath this building as well. It kind of works. Or here underneath this. This just looks flat and boring, and then you turn it on, and it kind of works. And then I just I pack it into a DDS file, which is pretty handy for several reasons. So if we go to refinery, which was the level we just looked at, and we go to refinery binary data. We have the light maps here. I just use render doc to view these DDS files. They're kind of handy for that. So this is what it looks like, the actual map. And I compressed it to BC7 because I couldn't really see any difference between like compressed or uncompressed files. So BC7 sRGB, and here we have the base that we just looked at. There's the house that we were inside. This is the terrain, and then it has like a whole bunch of slices. So these are probably like cliffs, and that's mostly cliffs as well. This is some sort of house, probably. Oh, this is the ramp up to the refinery. Yeah, there's the ramp there. What do we have? Here's another terrain. There's a smaller terrain. More cliffs. And this is the elevator, like the big construction with all of those beams and things. Yeah, some of these look kind of nice to just look at. This is the power station that we just looked at. I can recognize some of these shapes here. And these are probably like more rocks and things. That's the gatehouse. That sort of stuff. And then we have like trees and whatnot here at the end. Tree trunks. And that's kind of handy because then you can see actually what it has done. And then in addition to that, that's like 10 megs. Then we have a layout file, and the layout file then specifies the coordinates and all of that, so it knows how to find those. Stuff like that. All right, guys. Let's do one more thing here. Let's do one more thing here before wrapping this up. I need to actually go do some family business later on. But I think I have time to do a little bit of something still. That's the mod code. Let's close that up and then go back to the game code. So now we have the bed mesh component name here, and we can now do something like, if I can remember how to actually do it. I think it is on object created. If we go self context get, no, it's not that. is it? Game object get mesh component data. There we go. All right. So let's store actually a pointer to the game object because most likely need to have it later on. That will be basis basic game object pointer is null. And maybe we can even do it here in create. So self game object is self context get game object. Yeah, technically, I don't think I need to do anything here. Maybe we'll do it anyway. Yeah, I'll show you what I mean in a little bit. Let's do bed mesh data. That would be basis. It says render, maybe mesh. I need to remember where these things are. Self game object get mesh component data. That returns a mesh component data, which is in components. Okay, components it is. So basis components mesh component data, and I think everything here is initialized exactly. So you know it's just default value essentially. And in on object created, this is the place where we are supposed to we're supposed to be sure that all the siblings have been created. That's the difference between create. This is called when this component is created. And on object created is called when all components have had their create function run. So let's do self bed mesh data is self game object get and assert mesh component data, right? And he wants the short name, and we happen to have the short name, but let's do something like this: assert that self dot blueprint properties is not null. Actually, we don't want to give it any message. It's kind of obvious what's happening here. BP props, because blueprint properties is an optional pointer, right? It has this question mark here, and we want to sort of assert that we indeed have one, which should always be the case, but just to you know, if someone forgets to add those blueprint properties and they use this component somewhere, it's good to assert. So bp props dot bed mesh component name str, like so. So now we're asserting, and this actually just does the same sort of thing. It gets the mesh component data and it asserts could not find mesh component data, blah blah blah. So it should be kind of obvious what's wrong if something goes wrong. Alright, and this thing now contains a mesh instance and a scene node. And the scene node is what we can actually then use to actually rotate this guy. So let's see, let's set orientation in space is probably something that we can test. Just to see that this actually works, I'm gonna do make an F32 here that I initialize to 0. And in update, actually we can just do self. Oh, one thing that we need to do. One thing that we need to do is we need to only get this on the client. There are no meshes on the server, right? So, again, if we are on the client, we want to self rot plus equals, let's do delta time. And then we can create const orientation. This would be basis math quaternion. Actually, we will probably want to use a whole bunch of quaternions here, so let's shorten that as well, like so. So then we can just do quaternion init rotation x self dot rot, and that gives us a quaternion. We're going to use to set set orientation in space. So we do coordinate space. This would be parent. Is it? Yeah, we can't rotate our local space because then it's no longer local space. But in the parent space, immediate update doesn't need to be true. So if this now works the way I remember, the bed should now rotate around its axis, right? In fact, it should even do it here in asset preview. Yeah, we have the bed mesh name set there correctly. Let's just try this out. All right, so that's not good. That is not good. That's not what I wanted. Yeah, we have the physics are still okay. They're uninterpolated, so they're a bit jerky. But other than that, it's okay. So that's not what we want. Oh, okay. I think I know what the problem is here. We need the bed mesh to have its own scene node, but it doesn't have that, unfortunately. And the reason it doesn't have that is because it's just set to be 0, 0, and scale to 1. So it just goes like, I don't need a scene node. I can just, you know, I can just use the scene node that the All right. Hello, people. Welcome back. Yeah, something happened to the stream. I think we should be back. Hopefully we didn't lose everyone. Anyway, that was a bit of a bummer, but hey, that happens. What I was about to say was, for this to work, we need to basically tweak the data a little bit for that vehicle, because it's initially not done correctly, or it's like it was just a quick test back when I did it, so it doesn't really surprise me all that much. But let's go into means, vehicles, and gripper truck. And it's very clear to me that this this bed here is sort of, actually I don't know how this tool kind of refocuses on the center of the mesh in question, but this bed has been exported like this, with the center of the world origin down there, And actually what we need to do here is we need to export it so that its pivot point is in the world center. And this is something that is a little bit annoying with Blender, that like if you actually want to export something, there's no way currently to export it as an FBX, at least as an FBX, with the world sort of at the pivot. The world is always at the world origin. Or the mesh local origin is always at the world origin. That's annoying. So we'll do it like this, and we'll do bed, like so. And now we can move it back if we want to, so that it, you know, it lines up with the rest of the vehicle like this. That's fine. I don't need to save that now. That's completely fine. Now if we play this, it will probably be all kinds of broken. Actually, we can even run it here. And you can see that our Zig code actually even runs here in the preview if the truck bed component is set to actually execute here in the preview. If we untoggle it, it just jumps back to where it was previously. But this position that we managed to figure out previously from the Blender file, that is where we actually want to put the bed mesh, like so. And now it is rotating as we want. It's just rotating way over the limits, right? So to do something a bit more sensible, let's do like a angle is it's just like a standard Zig steady math sine wave of self rot, right? That's the angles. It goes from -1 to 1, and then we can do a angle degrees is basis math remap float angle from -1 to 1, and new mean is 0 and 32, right? 32 degrees was what we discovered previously was a good kind of maximum. Oh, but this wants it in radians, right? I don't have any radians. Really? Do I not have angles to radians here? That's because we have degrees to radians here. Of course, the formula is not very tricky to remember, but a little bit. So let's see if this now gives us something a little more sensible. Yeah, look at that. Isn't that nice? So I wonder how we should set up those collisions. Would be pretty nice if we could do that from data, from blueprint properties as well. And we might be able to do that if we quite simply look at the where is it? We can use that one. Metadata, and then we do basis, and then we do I don't know, dynamic body transform component. Now look at this, because this is shapes. It's an array, so we can have multiple. Max length 16 is probably fine. Shapes. It's of type dynamic shape description, and that's basically exactly what we need, right? So if we add this here, we don't have any code to read that in Zig currently, so we'll probably have to somehow add that. But now if we go here, we can see that we have fixed position, bed mesh component, and then shapes. And here we can actually add now any of these types. We can add a second one, third one, fourth one, and we should be able to actually set up the collisions like this. They will essentially all be boxes, I think. But in theory they could be anything. But yeah, I don't know if I want to do it like that. But that might be a pretty cool way of handling it. Matt says rip. I don't know. Is that does that concern the stream? Did the stream break again, or am I just missing something here? Physics transform component shape description from JSON. So this is essentially what we would want to have. Yeah. It's a bit unnecessarily complex though, this thing. So essentially what we want to have is some boxes and some positions, right? A box is a position plus dimensions, so 2 vector trees essentially. And then if we want to be really fancy, we can also do like an Euler angle rotation thing. But I'm not sure we need that though. But what we can do is we can add a new type. So here we have shapes. It's of type dynamic shape description, right? And dynamic shape description looks like this, or like this actually. UI custom type. Yeah, so let's go here and add. I think this is how we can do it. Here we go. And let's call it box collision shape. Why not? Box collision shape. And it won't have a type. It will have a size, just called size, visible away, vector 3 111. It's probably fine. Size, shape box width. What? It's just size. Size, yes. And then we want to have a position. And maybe even a rotation. Why not? Let's have the rotation there. And then we take all of the rest of the stuff away. The stream is a bit stuttery for me, but still going. I apologize. I don't know what is going on now with my internet connection. I updated it recently, and it's been going pretty well. It's been working pretty well, but it's also been a little bit flaky in just like the past few days. That's annoying. There shouldn't be a whole lot of load on the connection now that I do these sort of code things. Then if I jump back to the game, it typically demands a bit more of the connection. Right, so we have positions, we have size, and we have rotation. Those should be everything we need to do any sort of box collision. So truck bed component, let's do box collision shape. Collision shapes. Like that, right? All right, we have another sort of disconnect here. How annoying. Well, let's keep going still. If we can manage somehow. I'm gonna have to probably end this soon anyway, but it's a little annoying with these disconnects. Right. So now that we have this, let's compile that. Make sure it builds. Missing struct field. Okay. That would probably have to be like... Let's see, I'm pretty sure I have initialized that in some handy way somewhere. Where have I? Yeah, okay, it's just that. Right, I need to initialize it, but it can just be like standard stuff, right? Yeah, that works. Okay, so now then. I'm not getting a phone call. 1 second. All right, sorry about that. It's not a very professional stream this now all of a sudden, is it? Can't be helped. Okay, let's add some data here. I just want to test this out. Let's add one box to the right, another box to the left, and a third behind the vehicle. Let's see if we can get those to show up as a sort of last sort of thing here. So I need to, of course, need to iterate over. So for props collision shapes, that's like the shape, like that. And what I want to do is try self collision shapes append a collision shape where the position is, and then we have this handy function here. We actually don't need that. We can just do vec3 init from slice s dot position and size is the same thing. and rotation is the last one. Right, that should work. And what we then want to do as a last thing is this. Let's do for self. No, actually not self, but here, blueprint properties. Yeah, we can do the same thing here. This. That actually should be only on the client as well. So BP props, we can use that directly. And we can do BP props collision shapes. And we want to do basically basis debug draw. How do we want to draw this? Let's just draw a sphere where the things are. That's just easier. Position, radius, I don't know, 0.2 again, and color, maybe just basis color white, something like that. We're basically just trying to see if we get that data to flow. It's not indexable and not array. Okay. I need to do dot slice. Right. Yes. That looks to be working. Error loading groupings command. Unknown field. Really? Really? Let's see. Let's export to this and see what the JSON actually looks like. That our just open it with that. That's fine. Should be here at the bottom. Oh, actually, yeah. I do want to reload that. Thank you very much. Here we go. So we have collision shapes, position, size, rotation. That looks good. Okay, collision shapes. Isn't that what we actually call it, though? Oh, right. Oh. That's not right. Collision. There we go. Typo in my definition here. Yeah, there's an I missing. There we go. That should be better. Oh, and now we need to probably reload this thing, right? Unknown field. Let's see if we can get this thing to show up. That was unfortunate. Yeah. Save that stuff. Collision shapes. Oh, we need to. Okay. I know. We need to reload the UI definitions. There we go. That's why. That's why it doesn't show up. Yeah, now we have the data here. That's good. And here we go. Cool. So now we can move like this thing to the right by just adding this like that's a bit too much. Now we have it there next to the vehicle, or we can move this forward by just doing like that. Yeah, and every time we save this, the bed kind of jumps back to the same position. That's why it kind of nudges like that. But okay, this is cool. I mean, these are not super useful as this, of course, but we can clearly see that the data sort of goes through. And with that, I should be able to set up the collision volumes or shapes for for the bed quite easily. All right, folks. This has been a pretty long stream, over 5 hours. We were doing pretty well in the beginning and middle, but towards the end, again, ran into some